So the recording in progress. Okay. So the co-organizers listed here, Kendra, Jan, Fabio, and Cristiano. And a special shout out to Cristiano for all his hard work. If anybody's looking to hire, Cristiano is smart, hardworking, dedicated, motivated, and he's the whole package. So please keep Cristiano in mind for your future hiring needs. Okay. So the goal here is to bring together a fairly large community internationally that intersects software engineers and game engineers. And we're going to try and encourage discussion and debate because people come in from all kinds of different perspectives. Software engineering is a huge area, as is game engineering. So when we combine the two areas, there's many interesting things to work on, many problems to consider. Looking at the research challenges, cost, development time, quality issues across entertainment games, serious games, and gamification. So this is a little bit broader than many of the previous workshops at this intersection, in that we're also focused on gamification as well. And we would like to see out of this discussion today, the presentations of the interesting papers, topics of interest, and how the future workshops could explore these many topics. So big bold letters here, we're looking for highly interactive, encouraged discussion, and looking for perspectives from both academia and industry. Because you know, each group has got its own special interests, and we need to help each other proceed in this very interesting and important area. Program committee, many thanks to the program committee for their reviews, and of course, no one in here is the dreaded reviewer too. So we only have positive, enthusiastic reviewers in our program committee. These are listed on the workshop, the homepage of our workshop as well. So if you'd like to contact anybody, please feel free. So we had a fairly small number of submissions this time, 3 papers, out of them 2 short papers. Unfortunately, one of the papers was rejected as a desk check for the scope. Just was not focused on games. So here's the here's our program for the day. We'll get going right away with after the opening with 2 mini sessions on paper presentations, and followed by our keynote and a discussion, a roundtable discussion towards the end. So I've got the first session, so I'll just keep going here. Okay, and I'll leave it to you guys to you know, pipe in with questions, etc. As we go. And allow me just to introduce the first paper presenters here. It's on papers called Automated Game Testing Using Computer Vision Methods. Cyprian, Alain, and Maruna. The abstract is here. So as the presenter gets a little bit organized, perhaps. Ready to go? Cyprian? Yes? Yes, okay.
I'm here.
All right.
Yes.
Then I will hand it over to Cyprian.
Yeah, you can. I would like to share the screen if possible.
I'm out.
Okay. Tell me, please, when you can see the screen.
Yes, very well. Thank you.
Oh, okay. So I'm Cyprian. I am the presenter of the paper. We have the things that I am going to present, the set of tools and everything that we discuss is open source. It is at this link. You can find the link in the paper. The paper was sent in Discord as a public link too. You can find it there, or you can contact me if you have any other questions. Well, the agenda, I will try to introduce and motivate why we do that. Then I will try to tell you exactly the problem that we identified in software testing regarding games, especially games field, with our industry partners, the methods that we proposed that apply computer vision to this field, some implementation details, the evaluation, and some of our future work plan. So first, why do we need to invest in video games? If you check the reports last year, you'll see that video games are now a very important part of the entertainment industry, and they even exceeded the ones obtained from movies or US sport markets. Yeah, one of the issues that appear, and I've worked for several years, and I'm still working in collaboration with the industry partners in the developing games and methods. One of the issues is that always the deadlines are very tight. Many times users request new features and so on. There is a very straight process regarding to updating the game titles and so on, live titles, and overall this decreases the quality of the software developed and causes bugs which usually decrease the overall experience of the users. Also, we identify that most of the testing process is done manually by QA people, and we try to maybe we can cut the costs, or maybe we can try to create less work for human mind, maybe to concentrate on better topics. And we started to compile a list of problems with our industry partners, which I telling you from beginning. It's about Ubisoft, Electronic Arts, that are here in Bucharest, and they were very keen to give us some hints, discuss with us. Also, members from our paper are working with them. So we group these problems, the problems that needs significant human effort in a few categories. One of them is, the first one was UI testing. For example, if the user shoots someone, is the score increasing correctly on the heads-up display, or did a certain menu appear on the screen on the right context? Is the ammo displayed correctly on the screen in sync with what we should have? These are very, I'm telling you that this kind of problems that we evaluated are very repetitive tests that needs to be done effectively, especially around releases almost daily, to be sure that the new code developed is of good quality and doesn't break anything. And because these are being very repetitive, sometimes human mind is missing some points in here, and yeah, and they cost a lot. Then there is animation testing. For example, if the agent stays somewhere and watches a character animation, is moving in the right direction for a sequence of frames. Then the rendering tests, which if you have a low condition, is some kind of post-processing effects appear correctly on the screen, or is a binocular item appearing correctly positioned on the screen. Then the physics, if you push an object did it move correctly? Did it respond correctly to your request and considering the right weights and some kind of physical constraints? From the gameplay perspective, if you respawn someone on a map several times, it is in the safe area, it is spawned where it should be. If you press a button, for example, to enter in a car, in the next couple of frames, are you seeing the character in the car or not? Our motivation is to automate this kind of processes using visual feedback from the game and try to this way to reduce the costs and scale these processes with hardware resources, which are in general easier to get and cost less than human resources. So our proposed method now, after we studied or the state of the art in this field, we identified that there are a lot of implementations and papers that discusses game agents that can play a game either automatically or through scripts, and many methods are behind. In the last year, we all seen a lot of reinforcement learning agents, for example, that are able to play the games and explore the states and so on. So we try to address this issue, this thing from a different perspective. Why not leveraging the existing work, like the existing agent, being them scripted or AI agent, and just analyze the output of the game from both sides, from both the visual images and the internal game state that could be or could be not exposed by the game developer, so that you can work independently. So now, if we try to, I'm in this presentation, I'm not trying to be very abstract. I'm trying to keep it high level. You can find all the mathematical details and the minor things in the paper. But for now, let's suppose that we have, for test specification execution, we have a set of tests which are composed of several maps from state and action to the expected behavior, where the state is the internal state of the game, okay, the context that is exposed by a developer. The action is in our representation, one hot encoding representing one of the action type code name, for example, jumping, moving, firing, and so on, plus a kind of dynamic array of floats describing the action. The expected behavior is a description of what should happen. For example, the character should enter in the car when he was in a state near to the car, and the action is pressing the button for entering the car. Okay, this is a concrete example. And the expected behavior in the next 5 frames should be that your character is in the car, inside the car. You can see from this specification that this kind of test is dependent of the game mechanics engine or any other implementation. So the runtime mechanism to explore this set of tests is to first, let's say we have a game agent instance, whatever it is, a reinforcement learning agent, a classical one, AI, scripted. We have a runtime component that checks the internal state of the game and builds a compatible set of tests. So T-compat is a subset of the T, is what tests are available in the current context. And this corresponds to the right state, being in the corresponding state. And let's say we pick a test from the compatibility test set. We execute it by running the test action. basically this map over this pair over here. We do the action. For example, we press the we send to the agent the command to enter in the car, and we consider the test correct if the output of the game is the one that described in the test expected behavior, where the expected behavior could be it is the union of the visually rendered feedback and the internal game state that has been changed, the delta basically from the previous frames. In our framework, we created a tool to prioritize this set of tests. But human, for example, can be automatic, and there is a live tool that can balance them. There are many methods and strategies that can be used, and we plan to do in our future work. For example, checking which tests have been run, have found in the past many issues and so on. There are many things to address regarding this topic, which of the compatibility tests to select. And let's speak a little bit about the methods that we concretely use. For example, for the text recognition, we use currently Tesseract from OpenCV. This is an example from the Unreal 4 engine that we integrated with our framework, where we want to check that when the AI is starting to fire against enemies, the visual ammo box is updated correctly. So what we consider, the only thing that we consider is that we know the relative position of the UI text, such that we know where to read it from. There is also, for example, we would like to check if the visual elements exist or they are correct on the screen. And in this purpose, on the same demo in Unreal, we check if the weapon cross is correct after the weapon switch. In this case, we are using the OpenCV standard template matching algorithm, where we compare the cross of the weapon with the one on the screen. So if the AI changes, when the AI changes weapon, basically a test says that, okay, this is in the compatibility test because it's the correct thing, is one of the things that can be tested in the current context, and it checks basically if as the expected output should be that the cross on displayed on the screen is the one with the correct weapon selected, the new weapon selected. Then this is another example in Unreal 4 car configurator demo, where we trigger the agent to enter in a car, and we would like to see if the agent is really in the car or not. So what we do in that case is to record some visual features and then use the YOLO algorithm to identify the objects on the screen. We retrain the YOLO algorithm basically on some kind of features inside the vehicles in this demo. And you can see here that after entering in the car, the model recognizes the bounding boxes for mirrors, the well, and the computer board over here, navigation. We had to, as a note, we had to use different camera angles during the training of the model to ensure that it doesn't overfit. Otherwise, the results are very bad. Then we have the animation kind of testing. So how do we test the human skeletal motion tests? How do we perform them? And we use the open pose method. You can, of course, you can stop me at any point you want to ask questions, or you can ask them in the end. The details are on the paper, however, or we can discuss later about them if you want on Discord. So we use open pose methods to identify the skeleton of the character. And then what we do is to check if the character is moving correctly or is staying correctly on the ground. For example, here we have a case where a failed test where the agent, or one of the agents in the game was killed, but he was in the Unreal Engine, the same shooting demo, but he was staying up on the ground instead of being laid down. So we got this bug with open pose and analyzing for a sequence of images to confirm that. There is also, this is a Unity 3D game. Also, the perspective is isometric. Trust me, that is a 3D game where we try to do object motion tests. And what I mean by that is imagine that for example, in the left figure, we have this tank which is firing a projectile. And we would like to be sure that the projectile direction is the one, is the correct one. For example, you see it graphically here, visually, that the projectile was shot in a certain direction in internal game state. And you would like to see that that the projectile is actually moving into the right direction, because there are many bugs sometimes, like is moving perpendicular and or in upwards and so on, because of new code changes. And a human tester can easily spot this kind of bugs. But how does a machine can from visually rendered image understand these kind of motions? So we came up and implemented a solution in our framework. And this is based on the Unity demo called Tanks that we also published online in our, and you can see the repository on the paper. So the algorithm behind is using 4 steps. So the first thing is to be able to project from the 2D space back to the 3D space, because what you see as a machine and as a human user is a 2D space, is an image. Okay, so how do you project all the coordinates on the 3D back? Of course, there are we are basing our methods on the existence of static objects in the screen, which always exist in games usually. And let's say we have 4 points, like the one the red one marked with cross over here. What we do in the first case is to say that these are the ground truth locations. We have this source location of them, both in 3D and 2D. And what we do is to compute a homograph matrix transformation that is mapping from the source to destination, from the 2D to the 3D space. By using the inverse of this matrix, okay, you can find all the details in the paper, then any arbitrary point on the 2D image can be projected back in the 3D space with a little bit of noise, but it's acceptable. Then having we use the same YOLO method that was retrained on this demo to address the problem of finding the tanks, objects, and so on. And what we do is to convert from the image space to the 3D space back. Okay, so we get the coordinates on each frame of the objects for both tanks, projectiles, and everything. Then we can work easily in the 3D space. Yeah, so this is the point. And the motion is analyzed as you would like to do. Like you can compare the velocity of the objects, and with a desire, with a specified threshold, you can quickly identify if the motions are correct or not. Regarding the implementation details, we try to use a separation of concerns as much as possible. And as I said in the beginning, but it's not on the UML diagram, we have two entities, basically the game bot, which is on the game side, and the game state checker, which does the evaluation. And typically, this would be deployed externally, because of many constraints, because the games could run on embedded devices, they could run on mobile, they could run on consoles and so on. Also, you don't have processing power, because you always know the frame rates of the games are very tight in general. And you would like to perform this kind of analysis, being it online, but you would like to put it on an external process that has strong GPUs, that have computing power, because you don't have that kind of power on a embedded device like a mobile phone. Okay, so what you do on each frame is to build a corpus of the T-compatibility set. You send the ones that are the one that you select, or ones that are available in that game state, to the game state checker, which is deployed within Flask in our set or sockets in our test suite or in our framework. Then it will turn back the validity of the test, and you know it on the game side if if the test was correct or not. You know it on both sides, but the main thing about the implementation is that we try to separate them as much as possible for both performance and developing them in parallel. As tools, as I mentioned, we have a layered architecture where at the foundation layer we have the OpenCV, TensorFlow, OpenPose, some sound processing tools which are not addressed too much in the paper but are new, and you can find them on our repository. Some other small libraries that helps us emerge. Then we have a kind of logic layer that implements some kind of special purpose functionalities that could be, these are the kind of functionalities that we are relying on game developers to write that are specific to their games. And then we have the game state checker and the communication layer. There is one last thing about the implementation details is sometimes the machines are not capable of running Python code, and we rely too much on the Python on game state checker because it is simpler to use and to leverage the existing ML work in the field and deep learning. But we address this problem by having like an adapter which works with sockets. So you deploy, you can always in C++ or C#, you can use sockets communication between embedded devices like consoles or mobile phones, send them through a socket to a deployed adapter, then the adapter will send to the game state checker. As you can see the details, I think I'm running short of time, right? Because you can see the details on the papers regarding the evaluation, but to be sure, we have seen for the text accuracy detection, we have identified that it's more than 95% for ammo detection, the name of the weapon, the name of the characters, and so on. The template matching was kind of good, 88%. Then on the car configurator demo, we got 100% accuracy, but we didn't have too many vehicles to test on. For example, I imagine that we could get the entire data set of Grand Theft Auto vehicles, and we try to retrain on that. The accuracy will get lower for sure because they have a lot of vehicles. For the motion analysis test, it was almost 90% of the time it was correct. We also, in our test methodology, we try to intentionally do 50% intentionally failed. and 50% correct test, just to be sure that we recognize both situations and we do not have like an unbalanced set of tests. For the future work, we would like to try to test more on specific game genres. For example, what kind of testing should be done more or less for strategy, for sports, if there are any particularities regarding them. Also, improving the accuracy is an important thing, because we saw in the Unity demo that when the particle effects like dust appeared, the accuracy was decreased. For example, the accuracy of for detecting the projectile only from visually rendered image was a little bit decreased. We would also like to automatically identify opportunities for testing, leveraging the blueprints concept. Okay, because there are many developers nowadays which are scaling their development of design on the game in this kind of blueprints or visual programming that designers use. Also, we have a kind of starting collaboration to perform robotic process automatic (RPA) for UI testing in the games. Okay. Thank you for your time. Sorry for being a little bit over time. And if you have any questions, if you don't have right now, you can always send me an email or ask me on Discord.
Okay, that's great. If you've got a question, maybe just pipe in, turn your audio on, and fire away with questions.
Yes, absolutely. So super. Thank you so much, Cyprian. And you have two questions in Discord channel. Maybe
Okay.
Shane, you can share with us your question.
Sure. So I'm just wondering about the characteristics of the compute workload for model training, retraining, applying to testing examples. Like, do you have some benchmarks for that?
Well, yes, it depends. It depends on the model that you use and the data set that you try to retrain on. For example, in the car configurator demo, there were like 5 cars or so. So it was very quick. It was less than 30 minutes to retrain the YOLO model on it, because you are taking the already trained model and you just fine tune a little bit for your new models. So it's, but as I said, if you have a huge game like Grand Theft Auto with lots of cars and so on, it will take, maybe it will take a few days to train it very well. You are right about your question, because sometimes if the design wants to put 100 cars the next day in the game, you have to retrain the model. Yeah, this is a problem. But it's not like I'm not expecting to have the designers or graphics to have so much power in the end to build so many models and to bring the new models daily in the game, such that our method is not applicable there.
Right. And just a quick follow-up, because I think like the training cost will scale with the cost of testing as well, right? So if a designer introduces a whole bunch of new assets that need to be checked in the test, that test is going to be expensive for people, and it's going to be expensive to retrain your model, right? So I just wonder if it pays off in the end to retrain.
I think it still pays off, because retraining is about computing power, and nowadays we have computing power, and the computer power, this kind of retraining is precise in general. And it costs less than humans.
Sure. Okay.
And Kendra, you have another question from Antonio.
Yeah. So
yes. Thanks a lot Cyprian, for your presentation. So my question is about the programming language that you use to define the test cases, and if you have some specific templates for the different type of tests that you can define and execute in a game in general, no?
Yeah,
So
yeah.
do you have a specific language, or?
We have, I'm giving you the link.
Mm.
It's a human kind of testing, and it's about behavior-driven development and testing with getting. So this is the starting point for understanding our methodology and how to write the tests.
Great.
Yes, it's very close to a human specification of tests, to a human language.
Okay, but it is just translated in some way
in the
in a
code.
local, so in a code very close to the game language, no, programming language.
Yes. So you can see that someone not only people with background in programming can write the tests. You can see from this kind of BDD method that you can write the test in a human kind of language. This human kind of language is analyzed by this backend tool automatically to give some kind of patterns, patterns, and you have, as a developer, you have the duty to interpret those patterns and implement the connections from your game to the tests.
Okay, so but
that's why on the slides. That's why on the slides I put this. This kind of logic layer. So the link of the functions between the BDD methodology that I've sent you in Discord and the game itself, it must be addressed by this.
Okay.
Yeah.
Thanks a lot.
I have one question. So, what kind of bugs or issues you imagine is more potential for your technique? So there is some specific issues that you could realize that may be more focused on, or more in general?
Yes. So in general, I think that one of the issues that could limit the performance of the visual of the visual understanding of the scene are the rendering effects that often appear. For example, when you have a log, when someone shoots you and there is a lot of noise in the scene. Even in the simple case with the Unity tanks, when they were moving too fast, there were a lot of dust created, and the projectile couldn't be found by the YOLO model. So, as a method, you could, of course, try to inject that kind of and retrain the model, but that is difficult. You can't do that for everything, and with that rendered noise, you might have issues. But even like that, even if you obtain like a 70–80% things, what I imagine you could do is to put some kind of threshold, for example, or say like a safety threshold, and that would trigger a test that you are sure to be that is failed. So maybe there is a range of thresholds regarding the safety that you are not sure. Then you do not say nothing from the framework. But if it goes beyond the very low threshold, then you say something. If the projectile is moving in upwards or in a perpendicular direction, it will go right away in your front, for example.
Perfect. My 1 second question, just to finish this. Your tool is more, your approach is more for quality assurance team or more development team, I can say, because sometimes the teams are divided because the black box testing, but your approach is more open, say white box.
I think it's a mix. I think it's
okay.
a mix. And in general, I think that testing efforts should be more like a mix, because I believe in this kind of BDD or TDD kind of development. We have to start thinking like this, instead of writing the code and letting others testing the end product and coming us back with bugs. That old methodology, I think it's going to fail with the new kind of expansion and scaling of the products.
Absolutely. So thank you. I don't know, you don't have more questions in Slack, in Discord, but if you would like to do more questions and share, and if the micro is open, just to share your questions here. But maybe you can go further, Kendra.
Okay, let's
Yeah, I will stop the sharing.
okay. Let's get back into this and move on to presentation 2, which is a short paper called Rebuilding Games at Runtime. Diego and Claudia, whenever you're ready, please start sharing your screen. Okay, thank you.
Can you see my screen?
Yes, you can see it, Diego. But you cannot listen. Hello, Diego.
Wait, sorry, but I'm not seeing my screen in this.
You can
main
see your screen.
I can see.
Yeah, it's fine.
It's fine. Go ahead.
Ah, sorry.
The floor is yours.
No worries.
Hi, everyone.
No worries.
Hi, everyone. I'm Diego Cardoso from Federal University of Rio de Janeiro, Brazil, guided by Claudia Werner. And today I'm going to talk about the paper Rebuild Games at Runtime. This is a brief summary of what we'll be discussing in this presentation. Motivation, soft product line, mods, proposal, and final marks, and some feature works. The gaming industry is growing over time, have a considerable amount of fans. Games are one of the main entertainment sources, place the game industry as one of the most profitable, have billions of dollars been spent in 8 years. However, create a game can be very complicated with many activities, elements, team members, make some games take a long time to be produced. And because of this delay in launching the game and the large amount of games fans, this can generate a great nervousness and exercise for game population. With this, many fans of games end up creating their own versions. These modifications are called mods and involve the practice of developing modifications or adaptation of a game. This idea of use a game to adapt and create another is very similar to applying software use in a doc manner, which involves the use artifact to create new ones, pre-existing artifacts to create new ones. Software reuse has several approaches, such as components, model-based development, and software product line. Based on the game scenario modification, when a game is adapted to generate others, one possibility would be suggest the use of a software product line. When this approach is used, when a similar set of features is reused and some new are added to be the original game, generating new projects. Therefore, it's possible to imagine a game where features are created and modified, generating new mods based on the original game. Software production line is a set of methods, as I said, techniques, and tools for systematic development of similar systems, which have a common core and distinct behaviors. For example, think that there is a car, and from the car there are possible modifications such as cars with 2 doors, 4 doors, and CD players, for example. With the use of this topic of research, it's expected to obtain as results of reduction of development time, easier maintenance and evolution of the system, increase the satisfaction of the programmers, and high quality of the code. Software product line differs from others reuse approaches when comparing predictive with opportunity approaches. Rather than creating generic software components in a library in hope of using future reuse, software production line only requires create these components where their use is expected in one or more products. That is, something will only be created if it will be used. In general, in software production line has two stages: domain engineering and application engineering. The domain engineering is the stage where common features are verified and taught. In case of games are mechanics, dynamic, and statics like MGA framework. And application engineering is the stage where common elements are reused and specific features are added. In game scenario, domain engineer is where all game features are taught and where the game design document is created. In mod scenario where a game community is inserted, it's necessary to divide this application engineering in two parts. The first, where original game is created, and the second, where this game is expanded, giving rise to the mods. SPL in its essence needs to be defined at design time. The features must be described before running. So it's so important to establish the domain of application of the game that will need to development. A more recent view of production line is dynamic product line. This approach can be understood as SPL, software product line, where modifications and adaptations are made at runtime. In general, games represent there are any definitions for gaming literature, but in general, games represent activities that use abstract words in which decisions, actions, roles are performed, and as a recreational activity in form of distraction or entertainment. But understand what make a new game is not as simple as it may seem. By definition, games, it's possible to observe some features necessary to differentiate them, such as the roles, actions, and decisions. But it's not necessary to modify all these elements of a game to create a new one. There is a stage of modification. When these modifications are made by the community, they are called mods, as I said, and can be defined as abstractions of the development modifications of the adaptations in a game. There are several ways to organize the ideas for building a game, such as flows models, gameplay, features, among others. But a well-known and widespread model in game area is the MGA framework, mechanics, dynamics, and aesthetics. Mechanics can be understood as the roles and the actions of the game. Dynamics represents the behaviors that occurs as a result of an action. And aesthetics are the emotions expressed by the player. Combining all these parts, we can define a game. As I said, there are stages of modifications, and this stage change according to the degree of modification that's done in the game. The main types of mods are interface customization, mutators, add-ons, mods, and total conversion, and machinima. Interface customization is a modification in the visual elements, such as a simple change the elements that are shown on screen. Mutators that can be understood as an action of add minor modifications that do not change the gameplay and mechanics. Add-ons, there are extensions such as new maps or new objects. Mods can be understood like combinations of add-ons and mutators. Total conversion are some modification go as far as create entire new games, such as Counter-Strike, which has adaptations of Half-Life. And machinima, that can be understood as a change in the visual replay of game session. That is, modify the story or movie represented by animation. Bear in mind that most games can be described in general by MGA framework. It can be said that if exist modifications that occur in each part of this framework, like mechanics, dynamics, and aesthetics, it's possible to generate a new mod. Thus, a prototype game based on MGA was created where runtime modifications are applied to the game, create a new mod from time to time. The prototype create makes use the idea of dynamic product line applied to mods. How as I say, it's a prototype in an initial study, and because of this, some choice to facilitate development were made. The first was choosing to create an infinity game because it's a game mode with less complexity, and chose of dynamic product line to facilitate the coordination of modifications in create games. A mod is created by applying one or any modifications to a game in each part of MGA. In other words, each part of the game, mechanics, dynamic, and aesthetic, is modified. create a new game from time to time. On the right side, you can see some phase of the game that are create a runtime and the features that are select in each phase. The game basically use a tree with possible mechanics, dynamic, and aesthetics that can be selected. On the right side are possible to see the game features in three forms, and the left side in description of framework MJ. For example, in mechanics, it's possible to select points using coins or score, or moving as run and jump or fly, the option of lives in the game, and how to destroy the game objects or the enemies with bombs or clicking. Finally, the paper sought to demonstrate an initial study on the use of software reuse concept to create games, in this case mods, in more systematic, less costly, and quick way. For this, the concept of dynamic process line was used for creating an infinity game that modify its features in runtime way. As feature works is intended to evaluate the game with expected to see its degree of acceptance and thus raise more requirements. Finally, a new game is already being built that also use the production line to generate games, but this time it will use the production line instead of dynamic production lines. On the right side, you can see the production line selection menu of the new game. Here are the references that's used in this presentation, and thanks so much for your time.
Okay, thank you. Questions?
In
Any
fact,
questions?
just a comment also, Kendra, because congrats, Diego, because this idea to try to merge SPL and games is not trivial at all. Good challenge, and you try to push on this automation.
It's
Congratulations.
an
I think it's a
initial
nice
study,
idea.
but I'm trying.
Sure.
So I have a question for this. Can I?
Yeah,
Go
go
ahead,
ahead.
Antonio.
Yeah.
Okay, so about the specific techniques that you have used. So product line and dynamic product line is a very broad research area, no, in general in software in the software engineering community. But did you use some specific techniques like, I don't know, future modeling or some specific tool to manage the variability of the games? So can you add some details on this or some links on this?
Well, this is an initial study, but in future, I'm trying to create an engine with combine games and software use, like you have SPL for create your game. Like you define your features and you select that you need for create your game. But in this initial study, all features must be created to be integrated like in product line. However, there are still games that have some problems. For example, because there are many features, I cannot see all phase that could be created for is a specific phase. For example, something like a star algorithm could be used to check all phase, but which wasn't done. But in feature, I'm trying to create this engine. The second game that will be built, I'm trying to create. I'm defining the features, but the end users select the features that you need in the game.
Yeah. This is a very interesting topic in general for this community. That has the goal to put together game stuff with software engineering. So, in my opinion, the first step forward this solution should be to derive a kind of body of knowledge, of this community, and try to derive the main features that must be defined as a types, and when you have that, probably you can apply any product line or already existing solution to model the future models and also to derive in automatic way the different instances of the games. But I agree that this is a very challenging research. Congratulations.
Thank you.
Cristiano, you have a question, no?
Just a quick question. It seems to me that do you know, Diego, Mario Maker? Because in Mario Maker, what they have is a scope where they have you can do many things, and then you choose what things you want to do. You can kind of create your own design. Is it more or less what you want to do, or you want to do some things before that, like in the requirement phase?
The second game is like that. You said you select the features for gameplay and create your game, but the game presented is the game selects the features without an end user, like the features are selecting runtime execution. But in general, in feature work, I trying to create this engine, but it's so difficult because you need to define all features. For example, have so many types of games. For example, arcade, Mario, and others type of games. And for this, you need develop the game in a specific way for use the product line, and with this you can select and create a game.
Yeah, that's why I mentioned Mario Maker. Maybe you should focus on one game type, and then we can dive deep into that. Because in Mario, you can your scope, you're restricted to that, and if you try to embrace the world, you might end up creating a general purpose game engine, and then we're not going to finish in time.
In literature, there are any other studies that use this idea. For example, SPL for arcade games, SPL for Mario, SPL for Donkey Kong. There are many, but I'm trying to use concepts of software reuse, in this case, software product line, in an engine that the programmer can use this for create new games in quick way, and not only use software product line, but others aspects of software reuse. For example, components, model-based development, and to other notes.
Yeah, we look forward to the future works then.
Yeah, absolutely. But Diego, do you imagine that you can integrate your approach in a game engine environment as Godot, for example, or something like open like that? What do you imagine to integrate this approach in a game engine?
I'm thinking about like there is a specific model that you need to follow these steps to create your source code in these specific steps, and for this you can, for example, you have specific features, and with these specific features, for example, graffiti, you can application a mutator, for example, with this tend a little bit this graffiti and create the tree of the SPL. And with this, you can in the engine, you select all features that you need, and this the engine creates our game. But is initial. I'm
Okay.
have some difficulties to try solve.
Oh, congrats. It's a short paper. It's a nice idea. I hope that you, as Cristiano said, you can see your work further. And congratulations. I don't know if you have more questions. No, Discord, you don't have more questions, Kendra?
Okay, well, perhaps we'll wrap this one up and move on to the all-important coffee break. And perhaps we could trim off a few minutes on the coffee break, catch up a little bit. We're running behind, but I think the discussion is very interesting. The questions are great. And so perhaps we'll come back in 10 minutes if everyone is okay with that.
Yeah.
10 minutes?
Yeah.
Okay. All right. We'll catch up with you in 10.
10 minutes.
10
but
minutes.
If you would like to discuss it, the room is open.
Yes.
It's a coffee break or water break or bathroom break, what do you want? But come back, because the next one is Antonio. It's a great talk that you will listen.
Yes, and I'll ask you, oh, sorry, I was just going to say, I'll ask you between sips of coffee, please join the Software Engineering and Games Research online communities. There's one for LinkedIn and one for Facebook. And we're sharing all kinds of announcements there, jobs, books, of course, workshop, conference announcements, everything interesting at this intersection of research topics.
Absolutely. And also, you have 19 people, but if you would like to share something, you can use and connect in Discord to share something or create this community, improve that. So feel free to connect in Discord. Discord is in general, a game platform that people use to share. So that's why we choose Discord. It works well. So I hope that you can use the Discord too. And you have now 18 people. So it's nice for me that see that the workshop, there is a lot of people sharing and participating. So super cool, because it's not an easy topic. Automated software development, it's not trivial at all. So that's why you are here, because it's not trivial. So congrats, Diego, another time, because super hard your work. And say hi to Claudia, because she's an expert in SPL. So put together. Probably you love Diego gaming. So doing something in gaming is nice, because put Claudia, that's super traditional software engineering researcher, with someone working in games, is super cool. Huh?
Exactly. In initial was difficult to convince Microsoft Claudia to
I
agree
imagine.
with this idea, but in I'm
But
trying.
you are doing a master. That's it, Diego, or
Yeah,
PhD.
yeah. In master, I'm create a game to teach software use, and the game use metrics to verify your codes. For example, you have an algorithm, and you need to use components to resolve this algorithm, and the the game use metrics to verify that how verify the acceptance if your code is reusable or uh, well codified and another metrics. I'm not remember the name of metrics, but I'm using 4 metrics to verify the code created for the user. And now I'm trying to create this SPL or use other concepts of software use in games.
Nice. And it's absolutely here. A lot of people are interested about to integrate, as Antonio said, integrate these topics of engineering in games. And I hope that you can maybe share more in the future and create more relationships with this community, or maybe to visit us in Canada. Shane, maybe try to invite the guys to visit us to collaborate on that.
Yeah, of course, but we have a lot more snow here than you have in Brazil.
Yes, no, but first we go to Rio de Janeiro. After that, it's coming here.
Okay, you get some balance.
Yeah, sure. Rio de Janeiro is a nice place to visit.
Yeah, I still haven't been, but I want to visit there in Sao Paulo.
There is guys that say that in Rio there is just 2 seasons. Okay, is the summer and the hell. Just the 2 seasons in Rio de Janeiro. Summer and hell.
Right. Yeah. Yeah, they say the same thing about Canada, that we have two
Winter and
seasons,
hell.
right? Well, winter and construction.
Sure, absolutely true.
Yeah, you have to repair everything to prepare for the next winter, right?
Yeah. Sure. Good point. Especially in Montreal. Montreal is a
Yeah.
nightmare of the construction.
It's
Mathieu
always-
lives there, so he can confirm that Montreal is the city of constructions everywhere, every time. And Cristiano too live in Montreal, so the Canadian
The orange cones everywhere, the classic.
orange cone. Yeah, sure. Kendra live in the west coast. It's not a lot of snow, so no worries about snow.
Well, actually, I'm in Kelowna, BC, so we have 4 seasons, but it's not as severe here. The winters are quite mild by comparison, because we're in a valley. We're surrounded by mountains, but we're in the valley, so we're protected a bit down here.
Right.
But we do get a winter. It's just not it's not as harsh or as long.
But this year the summer was super, super hot in BC. So.
It's funny that Kendra said we have 4 seasons, right?
Yeah.
When- in Montreal, we have only 3, right? There's no spring.
Yeah. Climate change. So I hope that next time you can meet together in presentially. Maybe you can have a hybrid, maybe workshop next year. And
We'll meet in the metaverse.
no, not at all. No, I hope not. Okay, no, sorry for the. I'm not sure if metaverse will be a good place to visit, to stay. But it's a nice debate, huh, Ali? Do you have some experience to use or not yet? A little bit skeptical about VR as a massive immersive environment, but maybe. You know, this year I helped to organize the ICSI conference and super stressed with the platform. Now, that's why we choose to use the simple and more friendly tools, just the Zoom, Discord. You can share, you can talk, you can control, no stress. The floor is yours, the workshop is for you. So feel free to participate, feel free to share, feel free to stay mute too, no problem. And just enjoy. Because in Nix, especially super stressful, the stuff about timing. I agree that you have control the time and be on time as much as possible, but without the stress that you had in last season. But maybe you can restart and I think it's people are there waiting.
Okay.
About the Antonio's talk.
Yes,
I'm personally waiting for it.
Everyone's anxious. Let's get started. Third presentation paper is towards a framework to assist iterative and adaptive design in gameful systems. Antonio, Enrica, and Anapola. Antonio, you just take it away whenever you're ready.
Okay, thanks a lot for this kind of introduction. So let me share my screen and especially my presentation. So do you see my slides, right?
Yes.
Perfect.
So thanks a lot, and I hope that with my presentation we will continue to push more ingredients on the table and for the discussion. So I'm a software engineering, so my research background is principally in adaptive systems, and I'm a researcher at FBK, Fondazione Bruno Kessler, in the north of Italy, where, like to Canada, we are waiting for a lot of snow for the winter to enjoy the winter. So in the last 3 or 4 years, I started to work a lot in gamified gamefold systems that are and another angle of games. And in this presentation, I will introduce a framework that we are implementing and we are using to design adaptive gamefold systems. So, as I said, our part of the coin is about gamification. So gamification is where we use game elements in non-game contexts. And so in the sense that we are not developing entertainment games with 2 dimensions, 3 dimensions, and so on, but we are implementing games for a serious outcome now, for a serious context. So in some way, we want to engage people to change their habits, and they need to contribute to the society in a very positive way, so through their changes. We do this exploiting a lot of game-like solutions. So and we developed a lot of applications in our context, especially with our municipality and in our city, for education, for mobility, for health, for example. So we have a lot of mobile apps and also desktop applications that are running now with the real clients, with the goal to push them in changing their behaviors and habits in different contexts. And we think that gamified solutions are mechanisms that we need to put together with software engineering. So when we develop an application, software engineering is not enough, especially in this kind of context. We need to have a gamified solution. So all the concept of the games must be there and must be part of the same software production. So as I said, gamification for engagement and behavioral change push a lot of objectives in real world challenges. As you can see from these slides, we have a lot of application for sport, wellness, for the environment, for the social, for the performance in a company, and for the energy. So there are a lot of mobile applications that use these game elements in order to push people to maintain their motivation and so on. So in our research center, we have developed a lot of systems, as I was mentioning before. One is Viaggia Play and Go. Play and Go is a mobile application for the municipality of Trento, where the goal is to promote sustainable mobility. So we want to push people to change their behavior, to use bicycles or public transportations or electric transport instead of their own car, okay, to reduce the CO2 emission in the city, for example. So we do this through a mobile app plus a set of game elements that we have in this app, like specific challenges or specific leaderboards, prizes to the best and more sustainable user, and so on. The second on the right is for children, is called Kids Go Green. Through mobility and through education, we integrate these two words together in a gamified system with the goal to incentivize young people to move in a sustainable way, and at the same time to relate the education. So they run a virtual trip inside in a classroom, and the virtual trip has a set of steps. These steps are done through education, through specific lectures and exercises, but also they are connected to how they reach the school. If they reach the school with parents without the cars, or with grandparents working a little bit in the morning, so they receive more points, and these points are accumulated to guide this virtual journey and to motivate them to use a sustainable mobility transportation means. So all these applications have been implemented using our framework. So in general, the picture that you see in the slides is a summary of the framework that we are proposing, that we have already started to implement. Some of these components are already running, and some of them are in a research phase, in a prototypal phase. But in general, this is the picture that we have in our mind, So we have three main macro components that are related to the design phase, to the execution phase, and to the interaction phase. So through this presentation, I will give you details on these three phases and what we already have and what we are doing in this context. Let's start from the design. So design means that while we are developing a software application, we need to have the game elements in this application. This means that we need to have tools and techniques to model this aspect in the software. So gameful systems are represented conceptually from this slide. So we have the three layers from the lower layers that are the elements of a gameful system. That are the classical game elements, like the action that I do, the points that I receive after the execution of an action, the challenge that I achieve if I do some set of actions, the collection of badges if I behave in a positive way and receive some reward, like a badge, a green badge, for example, if I use sustainable transportation means. The leaderboard, if I compete with other people and I have a leaderboard where I can see my position in the score. The mechanics are components that put together these game elements in different ways. For example, if I want to have levels in my game, if I want to have a challenge achievement, if I want to rank people, or if I want to update the score of each single player in the game. The dynamics instead introduce the dynamicity, so the end purpose of a gameful system. So I want to push cooperation among users, so I want to push more competition. So indeed, we implement different type of dynamics. The engagement, if I want to push participation, and for example, one player can engage other players, and we assign points upon to this behavior. So elements, as I said, are the main building blocks of a gamified applications, describe how they interact. Mechanics represents the set of the rules that specify how the game should evolve for their participants. Dynamics represent the emergent behavior, how the players behave using the game when a specific set of mechanics are used. So today there are not so much tools for gameful systems. So what the developers do is they use their own knowledge in programming languages, and they introduce the game aspect in the code, but without a specific method and a specific supporting environment. And this will bring to introduce a lot of errors in the game part of the software application. And the same application is not very easy to monitor, So if you want to adapt the game during the execution, we need to introduce some monitoring facilities for this. So we would like also to reuse game elements in different games, as we have seen in the previous presentation. If you want to have a product line, we need to have techniques, to reuse game elements, or to reuse part of the already implemented gamified system in a different context, for example. And the monitoring, as I said, is an important aspect, because if we discover that the game is too slow and we have no participation of the players, we want to push more motivation, we need to adapt the game at the execution time. So we need to have to inject some game mechanics or game elements revised during the execution. So for this, we have implemented the GDF. GDF stands for Gamified Design Framework, or Gameful Design Framework, to design gamified applications. So we use model-driven engineering together with gamification to implement such systems. So this GDF is composed by a set of languages, as you can see from these slides. So we start from the game elements representation. We go to game mechanics modeling, until the game dynamics. So for each of these aspects in a game overall system, we have a specific language. Of course, these languages are in some way integrated in a unique and bigger environment. Of course, after the design languages, we have the utilities languages, no? So utility languages that provide our techniques to simulate a game during the execution or adapt the game, no? So if you want to inject a new content in the game, we need to have a language to do this. So we have developed this framework using MPS from JetBrains. This tool is used to define domain-specific languages, and it provides also interesting techniques and methods to generate in automatic way code from the models. So this is a classical tool used in model-driven engineering research community. So GML is the first language that we have introduced. It's for gamification model language. In this language, we represent the essential elements of a game full system, as I said, so the main building blocks. And as you can see from these slides, we have the language that is composed by action, badge collection, challenges, the game itself, the levels, the play, the concept of player, the concept of point, the team, and so on. Okay, this is the basic language for game elements. GAML is built on top of this core language, is for game model language, where we describe in some way the concrete game, not in a specific domain. If you are in the education or in mobility, we need to differentiate the type of actions, for example, or the type of points that we need to represent in the game. For example, for the data-driven action, we can have the kilometers done by the player through a specific transportation means, or the legs of a specific journey. Okay, the experience points are the how much kilometers, for example, the player does using the pedibus, okay, or walking, or using the electric bicycle. Okay? For each domain, we need to instantiate the specific action types or points types. At the level of design, we have the simulation language. So when we have defined the game with all the elements, we want to simulate some specific action in a specific context, and this language is used for this purpose, to simulate the execution of specific action considering a specific context. Of course, we reach the point of the deployment. So we have editors to define the game. For example, here you can see syntactically how the game can be defined through the definition of the points, for example, of the experience points, and we can give the details in a textual-based manner, as we are programming in Java or in another textual-based language. Of course, we have this with MPS. We can generate, for example, in this case, a Java code that represents the instance of the specific game through a model transformation techniques, and this will be deployed in our gamification engine. So this means that all the concept and the game rules that we have defined using the textual-based language will be translated in a real code that is deployed in our gamification engine. So regarding the second component, execution, so we are at runtime. So we have the language for the instances that manage the instances. So this means that we can, in some way, regulate how the different points and actions done by the players must be instantiated and executed for the specific player, no? And here we associate, for example, the specific action to the specific single player or a set of players that compose a team, and so on and so forth. So we are at the instance level. Of course, during the execution, we need to monitor the game, no? And for this, we have a monitoring language. So considering the specific instance, we want to monitor a specific state of a team or of a player, and to check if the specific variable has a specific value, no? And we can, in some way, use this monitor to guide or to derive an adaptation need for the adaptation phase. The adaptation language is used properly for this. So we are at runtime, we have monitoring the specific a specific monitoring property. We need to react with a specific adaptation need. The GADML is used properly to define these adaptation needs, to understand, for example, the challenge that we need to inject in the new game. For example, on the fly, for a specific player game instance, we would like to revise a challenge proposed by a specific recommendation system. So, for example, for a player, we say, you need to use your bicycle for this week at least for 200 kilometers, okay? And we can adapt also not only the parameters, but also the type of challenge that we need to assign to the player. Through the execution time, we have these data-driven profiling techniques. So we use the game status to understand this data, but not only the values of the game, also the social value, for example, the engagement of the user and so on. And through the specific algorithm, we generate the specific challenge that we want to inject in the running game. So the last component of the runtime is the gamification engine. Is a component that we have implemented in FBK. It's an open source tool that can be used for a specific prototyping, and it is a rule-based engine. So it is based on rules, and it can be used for any specific needs. So the internal logic is depicted in this picture, in the sense how we use the different languages that we have defined in GDF. So each language has a specific purpose and a specific connection with the gamification engine. So this means that when we model a game, we can transform this in a specific concept that we need to have in the gamification engine, okay? When we instantiate a game, we generate a portion of the database of our running system that represent a specific instance of the specific game, okay? When we simulate a game, what we do, we generate a unit test, okay? We generate a set of JUnit classes that we can run and see what's happened if we simulate a specific action execution. The game adaptation, again, we generate a new game content. So this means that we manipulate the database that we already have, plus with our adaptation needs. So this is also available in my Git. So if you want to test and use GDF, you can clone and use. This is an open source project, and we have also a video that shows the GDF in operation. So the game adaptation is the last aspect, in the sense that through an editor we can define a new challenge. As in the previous case, we can generate the Java code of this adaptation case, and of course this means that if we run this class, we generate the post call to the API of the gamification engine that inject the specific game content in the instance of the game. Of course, we have also an editor to define the specific challenge that we want to inject in the game. For example, here the challenge say that we need to define a challenge. So like the bonus type is the bonus distance. So upon to a certain distance done with a specific transportation mean, we assign points, and we assign 200 points for virtual price, and we assign the price 1 if the specific distance is reached by the player. And of course, this is injected in the gamification engine through model transformations. Okay, I can skip this. So this is for the monitor, in the sense that the same monitoring language can use to generate a monitoring properties. For example, I want to understand from the status of the player if a certain score is reached in a certain period, and I retrieve the state of the player from the gamification engine. This is the monitor properties that we want to check, and of course, upon to this understanding, I can generate an adaptation challenge. So the last is interaction, but it's very, very, very simple, in the sense our vision is that we need to have a research line in software engineering that is devoted to model a gameful mechanism and aspect in general. So is not the case right now. So we are pushing this in our research. If we want to create a gamified scenario, we already need this gameful aspect in software engineering. How we do this? From a real application, we catch in some way wrap the events from an existing application. Of course, the gameful application developer should develop using GDF the gamified part. But of course, if we want to gamify an existing application that is not native to be gamified, we need to understand what are the set of actions that we want to gamify. And we need to relate these actions to events in our gamification framework that I have presented. We did initial experiments on this. So we have implemented different tools in different domains. On the left side, you can see a gamified software in modeling and programming environments. So for example, we have gamified Papyrus, that is an Eclipse environment for UML modeling in software engineering. And we have implemented, and this is Puppy Game. Polyglot instead is a tool that has been implemented in the last year to gamify Visual Studio Code notebooks. So we give to the students the way to learn and programming languages using also gamification. So they execute exercises and receive feedbacks from the teacher and also awards if the student reach a specific level of the game through programming exercises. On the right side, we have gamified application for sustainable mobility. So Playing Go is one, and Kids Go Green is another one. So future challenges, of course, we need adaptive and personalized feedback to the client, to the user. So we need to provide adequate reports to the player, especially in the education domain. So it's not enough to reward people, but we need to explain why they are doing a specific action, what is the meaning of the game action, and for example, give feedback in terms of extra material or I don't know, suggestion from the teacher for a specific programming language. The second aspect, we want to have personalized and cooperative learning. So people together doesn't work. So we have seen during the COVID-19 that we need to personalize education. We need to provide cooperative gameful systems instead of only competitive. This is very important. And for this, we would like to use AI techniques for adaptive gamification to support the teacher in the process of defining and monitoring, for example, dedicated learning paths for the students. Okay, this is very important in the education domain. And of course, we want to create a community on this. And to create a community, we need to have an open source code, an open source repository where teachers, for example, can share their experience in games and can share materials, so exercises or games, and all the elements used in the gamified applications. So I can leave you a set of references on my last results on gamification and software engineering intersection. And of course, a book that I wrote in the last years that is related to domain-specific languages, but inside there are some chapters that are devoted to GDF and how gamification can be expressed in terms of domain-specific language, as we did with GDF. Thanks a lot for your attention, and sorry if I consume more time. So I'm here for your questions.
Okay, any questions?
Just one comment too. I was shocked, Antonio, because it's super, super cool. This is your work. Congratulations. Because
thanks a lot.
Honestly, when you start to think about the conference, I never imagined to receive great papers like that. So just sometimes you start a workshop to say, oh, just to put people together to think. But see your presentation today is a great pleasure. Thank you so much for sharing. to us.
Thanks a lot. Thanks a lot. And in my opinion, so the gamification and gameful systems is a little bit different in respect of games, but
Sure.
they have a lot of elements in common. And in my opinion, what is really missing now is the characterization of not games, because game theory is a well-known research field, no? But in general, games with the serious purpose, with serious context, is something that is not in some way clarified or defined in a strong formal way, no? And with GDF, we tried to take in some way concrete problems, concrete application that we implemented, and abstract from this concrete stuff and try to define a design framework, no, that can be in the future used also in other contexts, no, that's has the purpose to be serious context, no, with the serious purpose.
Cristiano, go ahead.
Thank you for the presentation, very interesting. I just, to clarify, not sure if I understand correctly the approach. When you model the game or the elements with your own language, you show that you kind of simulate the application and you create unit tests. How does that work? Could you elaborate a little bit more, if you don't mind?
Yes, of course, no problem. So let me share just a little bit the presentation so that I can go directly to the point. Okay, to the simulation. Okay, so here with the language, okay, so you express, for example, you have a game instance, okay, running as a relation, so you refer to a specific game instance, and you would like to express the set of game executions, okay, so the set of actions that you would like to execute, okay, in a specific context. So the specific context means the player has done previous actions, and the player has a specific number of points, okay, and you simulate what could be an effect of the execution of this activity reusing the actual state of the player, no? So this means that when you generate is not this the case? Probably I have no example here, but in general, through the monitoring, I can explain through the monitoring to be clear. Sorry. Okay. Here, when you can retrieve in a certain point the player state. For example, there is this player ID. This is a school, a specific school in a city. Okay, and this is the state of the school. So they did some trip with the cars, with the pedibus, with the bus, and so on, and with the park and ride trips. So this is the actual state. Okay. So if you inject an action, means that you would like to simulate the effect of this action. For this, you generate a JUnit test class, okay, that has as a context the state of the school, okay, as the execution action, the specific type of action that you want to execute. Your outcome is the new state of the school, okay. So and you want to check if upon to this execution of this action you reach a specific challenge, for example. This usually is used to check if your game rules are defined in a correct way, okay, and you can do this through simulation. So you would like to see, let's see that if the school executed this action, what will happen in the overall state of the game, okay. And you can do this to understand if you model the system in the correct way. You can also use this to understand upon to this action, what is the general score of the game, no? So if the school is improving so much in respect to the other schools, you want to reduce in some way their effectiveness, not to be in some way balanced with the others. And you would like to inject a new game content, like a specific challenge, a stronger challenge for the specific school, no? because in gamified system, I think the dangerous stuff is that if you model the wrong rules and you discover this at runtime, you have no chance to revise your game if this is a very static game. Okay, in this case, you can inject new content in the game. So with simulation, you understand that you can do, okay, what is the effect. With adaptation, you inject the new content, and this is in production in the sense that the new players can, so the players can see the new challenge assigned. I don't know if this was more clear or more confused.
No, it is very clear now. It's basically we're executing and see the outcome. Very interesting. Just one more small question. As you wrote the book, so I wrote a small domain-specific language using not JetBrains, but the other one, the Eclipse. Is it similar, or you use?
Good question. So I know Eclipse a lot in the sense I used a lot of times in my past experience. When I found MPS, I changed completely all my implementation stuff with MPS for two specific reasons. One is the portability and the maintainability of MPS. So you know that when you have Eclipse, when you need to migrate from one version to another one of Eclipse, you are in trouble, no? So, and the maintenance of your code that it will be related to a lot of aspects, like the new version of Java, the new version of Eclipse, the new version of the browser, and so on and so forth. So with MPS is completely different in the sense there is a very strong community behind MPS. So JetBrains is a company, and this is I think one of the open source code that they have released. So you can use for free. And the only limit that exists that is only textual based in the sense you cannot model DSLs for graphical stuff like UML and like this. But for textual based languages, I frankly suggest to try at least MPS and to see the differences. There is a strong community, very professional, and also for the transformations, from the DSL to the instance to the new language like model transformation or model to code transformations. They have a lot of facilities and examples, tutorials and so on. I really like it. And in this book that I suggested, there are also other experiences done using MPS, not only for gamification, but also for other application domains like finance or software, hardwares, cyber physical systems. They use a lot for a lot of domains.
Yeah, interesting. I didn't know about the MPS and the JetBrains because I remember being very cumbersome to work with Eclipse, but this was like 6-7 years ago, 5 years ago at least, during my undergrad. So yeah, thank you, Professor, for your presentation.
Yeah, no problem, no problem. So if you need also other materials on MPS, or if you need at least my experience on this, I can share you suggestions and other aspects on this. And of course, I'm open to also to extend the GDF with other aspects that relate to games, So if there are other needs that need to be added to GDF, so through collaborations, I'm open to use it to extend GDF, but of course to use GDF to model and instantiate new gameful applications.
Okay, are there any more questions? No, okay, then perhaps we can move on. Thank you very much, Antonio. Great.
Thanks to you.
Okay, so we'll move on to the fourth paper, presentation on metrics. Metrics for assessing gamer satisfaction, exploring the graphics factor. So it's very good to see some work emerging now on metrics. It's a good indicator for a maturing area. Normally the metrics research follows a bit later, it lags. So authors on this, Stylianos, Christina, Nicholas, Apostolos, and Ignatius. And just please go ahead whenever you're ready.
Okay, yes. Okay. Hello, everyone. My name is Christina Vogliotti, and I will present you our work entitled Metrics for Assessing Gamer Satisfaction, Exploring the Graphics Factor. Playing video games, as already mentioned, gained popularity during the last decades. The key characteristic of a successful game is user satisfaction. And when we say user satisfaction, we mean the willingness of the user to play the game again, to be fully immersed, etc. For ensuring the success of the game, requirements engineering is a crucial step. In contrast to software technology, functional requirements such as correctness, authentication, etc., are not the most important in game development, since they only set the baseline for success. Non-functional requirements are the most important for user satisfaction. For example, the ability of the game to create emotions to the user. However, non-functional requirements are specified by abstractness, and for this, we based on what Somerville proposed, that is, quality plans should specify the targeted property, which is the quality attribute, should have a success indicator, which is a quality metric, and the target value that when reached indicates meeting the requirement, and this is the metric score. Related work is divided into two sections. The first section includes studies that are related to user satisfaction factors, while the second one includes studies that assesses user satisfaction. Regarding the factors, Ham et al. Proposed 7 factors, and among others, character and graphics are ranked as the most important factors. Young and Pasquale et al. Also suggested that graphics are one of the most important factors which influence user satisfaction. Regarding the second section, which is the user satisfaction assessment, Abadzoglou et al. Proposed metrics that estimate user satisfaction, focusing on quality of graphics, while Pasquale et al. Focusing on quality of game scenarios. Our work, the presented work, is the third one of a series of studies that aim at proposing metrics for assessing user satisfaction. Therefore, our work is a replication of the study of Abadzoglou et al. 2008, and the reason is to achieve data triangulation and draw safer conclusions that are closer to the context of game development. By comparing the two studies, they share the same set of metrics, whereas the main difference is that instead of using images, we used pre-rendered videos, as you can see in the slide. 8 videos with different versions of the same scene was used, and we changed in at most 1 or 2 metrics in each version. And these videos were presented to 40 random gamers with different age and different gaming experience. The 3D scenes were developed with 3ds Max and Unity, And each video was followed with a question in which the gamer should rate the scene regarding the quality of graphics in a range between 1 and 20. Here is the metric sheet that was used from Abadjoglu et al. Study. Since the inspiration was based on still images, the proposed sheet does not propose any metrics that are related to interaction. It's, as I said, regarding still images. So number of entities includes the number of elements that are used in the scene, for example, objects, lights, textures, etc. Average size of triangles is the average size of polygons of objects. Texture size is the average number of pixels of texture images. Advanced texturing effects is the fraction of objects that use at least one advanced texturing effect, for example, bump mapping or displacement. Number of materials is the percentage of objects that link to materials. Number of lights is the number of lights that have been attached to the 3D scene. Environmental effects is the sum of global illumination plus fog plus global illumination plus fog plus shadow effects. And the average resolution, width, and height is the size of the rendering 3D scene. Regarding data analysis, we used the 9 aforementioned dependent variables and 1 independent variable, which is the average perceived graphical quality. For evaluation, we used consistency and discriminative power analysis. Consistency analysis assesses if the metric under study is consistently correlated with the quality factor by using their ranks. While discriminative power analysis assesses if the metric under study is capable of separating groups of high and low quality components. Regarding consistency analysis, we perform Spearman rank correlation and comparing the results with the original study. Almost the same metrics were statistically significant. Number of entities, average size of triangles, average texture size, number of materials, number of lights have statistically significant correlation to gamer satisfaction from the graphics quality. So let's check each one of them more analytically. Number of entities is positively correlated and is the most significant metric on how appealing the 3D scene is, meaning that including more objects, more elements in the 3D scene provides a more detailed visualization of the world and a more realistic scene. Average size of triangles is negatively correlated, meaning that the smaller the triangles are in a mesh, the more realistic the object is. Average texture size is also positively correlated. The better the resolution of the texture image is, the more realistic again the object is. Number of materials is negatively correlated to quality, which is a rather unexpected result. Intuitively, we would say that we would expect that the use of materials would improve realism. However, it seems that the use of more materials does not improve, does not change gamers' engagement. And finally, number of lights. The use of more lights enables more realistic rendering. The major difference to the original study is the average texture effects. A possible interpretation can be that in still images, the gamer, the player, can catch the detail of texturing, while in moving objects can be slipped to his attention. We move on to the discriminative power analysis. We visualize it through box plots. To achieve absolute discrimination, there must be no overlap among all classes of the category. And sorry, the only metric that achieves absolute discrimination is number of entities. We can move on to a second example, which is the size of triangles. And when the size of triangles is high, the quality deteriorates, while the difference between low and medium size of triangle does not hurt the quality in a substantial way. Although we've mentioned that the smaller the triangles, the more realistic the object is, there are algorithms for polygon reduction to boost performance. Therefore, the modelers, the designers, should find out the golden rule between these two. Summarizing, we champion the inclusion of metrics in the game analysis phase in order to control the gamers' user satisfaction based on graphics factor. Some useful implications to game artists could be that the more elements a 3D scene contains, the more realistic will be. And based on the results, we can note that the textures of the 3D objects are not necessary to be only high resolution images, since, as we've already mentioned, the details are not always caught by the eye. Here are some limitations. Due to the relatively small number of videos, we were unable to develop subjects that differ only in one of the 9 parameters. As we've said, we changed 1 or at most 2 metrics in each video version. Therefore, a larger scale experiment is necessary. Additionally, we might have different results if we do not isolate graphics factor from other satisfaction factors, for example, game speed or interaction or other factors. Using real games and not pre-rendered videos would allow us to identify interactions among the game satisfaction factors. An analysis of different game genres might also have different results. The reason why we used a neutral 3D scene, we have selected the 3D scene, is to boost generalizability among game genres. And in the future, we plan implementing the calculation of all these metrics as plugins for open source game engines, since this work enables the automation of quality control in early development stages. That's all from me. Thank you.
Well, thank you very much. Questions?
We don't have questions in Discord.
I do have one if no one has one. A very interesting work. Let me open here. I'm interested if you put another variable like frames per second and how it ends up with the gamers. Like we start with 24 and then you go 60 and then you go until 120. I wonder how it will be perceived, but that's just a mention. As for the question, when you mention the number of details or number of items, I forgot the name.
Number of elements. Number of elements. Yes.
Sorry. So yeah, if you go one more and then you show an example, but you show an example of a room. Yeah, that one. But the room is different, right?
Yes, it's not the perfect example, you're right. But we've noticed that if we have the same scene with less elements and, for example, less lights, to put less lights, or to put less textures, or to put less objects in the same scene, makes difference to the user satisfaction. They want the room, not the room, the scene, the 3D scene. I can show you, have a small video. I don't know if you can see it. It's over here. It's two versions of our scene, which is a village and a town with buildings. And it's this exactly the same scene, but we have changed one or at most two metrics in each version. So in some versions we have, for example, all the buildings. In the other one we have less objects in some buildings. And measuring their user satisfaction, we found out that the videos with the more elements makes improve realism, let's say, and gives higher quality to the videos. But we've made tests with all the parameters, but as I said, due to the relatively small number, we had only 8 videos. Of course, we cannot test it all the parameters and all the cases. Of course, it is very preliminary and initial work. We want to try it in the near future with other factors, as you've said, speed or interaction, because also game is basically interaction, and we've tested with videos. We wanted to test it with real games and to see how the quality changes, how the user satisfaction changes, and make some comparings to all these studies that we have done already.
Cool. Thank you very much. Just one more question. How did you get the satisfaction by formulary in the end? How did
they ranked here. It is they ranked the. Sorry, because it's here. I don't know if you can see it. They ranked each scene from 1 to 20 according to their opinion. We've deleted the outliers, the maximum and the minimum values, and we found out the average value for each parameter, and then we did the analysis that I've described it to you using consistency and discriminative power analysis.
Cool, thank you very much.
Thank you.
Yes, I have one question just quickly. Thank you so much, Christina. Congratulations for this provocative work, because I started to think about the game design community could be influenced by your work, but how to convince people that game design is something like that you can measure. I really love that. I really appreciate your effort, but maybe also how to convince game design community to use your metrics. How can you imagine to do that?
That's a very good question. To be honest, I don't really know if we would finally convince them, but as I said, we are planning to test it also to open source game engines, for example, Unity or Unreal Engine, that they already know it and they use it, and to make tests to see if our proposition is applicable or not. Because okay, we propose some metrics, we assess user satisfaction, but we have to test it basically in practice and to see if all these idea that we have in our mind is worth, let's say. So yes, we are planning to test it with open source game engines and see if it makes sense, let's say, or not.
That's great. No, thank you so much.
Thank you.
Hey, any other questions? Going. Okay, go on.
So
Oh.
just a short one, just a short
Okay.
one.
Okay, you snuck it in there. Okay.
No, so you're mentioning metrics for graphics in 2D, 3D, and so on. So in gamification, for example, there is a concept of narrative, no? So how you define a flow in a game, no? So from one level to another one, and in some way you have no 2D, 3D artifacts, but in some way you provide some way to interact with the game, no? So do you think the approach can be used also in games that are not with the 2D and 3D dimensions?
Yes, of course, it can be used not specifically in 3D. In the 3D was just an example. Here, our future goal, I don't know if we can finally make a try with all these factors, is as you can see here, according to Ham, the factors that he proposed, it has like scenario, which here it's the narrative part that you've mentioned. It has sound, community, game speed, game control, graphics, character. With this, it doesn't relate it to a 3D or a 3D game. We focused on graphics and we test it on 3D graphics. The metrics are on related to 3D graphics, but we can test it also in 2D. We can change a little bit some factors some metrics that are to 3D, for example, a number of polygons. It doesn't make sense to a 3D scene, so we can change the list of metrics in order to use it in a 2D scene, but we can also use it with other factors and see how all these factors interact to each other. I think this would be the most fruitful and unknown area that needs to that needs more research.
Yeah, I agree. I completely agree. And if I can add another point here is that there are a lot of game elements, you know, that where you can evaluate the quality. You know, for example, in my experience, the entertainment or the engagement, you know, of a user. So you can have, for example, the best graphics of your website or your gamified application, but if you don't implement the right engagement rules, you know, and the motivational part, that means I don't know, collaboration instead of competition between players, you know, or how you reach a specific level in the game, you know. So are different elements that we are interconnected to make a more general quality model, you know. So I see a quality model as a future model where you have a lot of quality characteristics, you know, and you can measure the different characteristics and see if you are really engaging people or motivating people.
Yes, that's absolutely true. We can propose something that if we use it with another parameter, it will be changed a lot. So as you said, we can have a perfect game regarding the graphics factor, but if the scenario or the interaction is not implemented correctly, it doesn't make sense. So yes, it is very challenging work. We will try to make some tests and see how it will go.
Okay, good.
Thank
luck.
you once more. Thank you.
Mhm.
We need it. Thank you.
Mhm.
Okay. I guess if there's no more questions, we will conclude this presentation. Thank you very much. And now
Kendra.
we move on to the next coffee break.
Kendra, that's
Yeah.
the point. Maybe you can, because you're a little bit late,
Yeah.
maybe you can go further, continue with the keynotes if you, what do you think?
Up to you. Up to you. And up to our keynote
Mathieu,
speaker.
Mathieu, our keynotes there. Hi, Mathieu.
Hi everyone. Yes, I'm there. We could go on
Right.
if everyone is ready to go.
Let's go.
All right.
Let's go, Cristiano, Antonio. It's people there. Maybe just to.
Sure, for me it's fine.
Kendra.
Okay, well, let's hand it over to our valuable keynote speaker, Matthew. Lessons learned from 5 years of automated software engineering for games, industrial scale, and future research directions. So I will hand it over to Matthew at this time.
All right.
Whenever you're ready.
So do you see my
Great.
slides?
Perfect.
Yes.
Your
All right.
camera too.
Cool. And you can hear me well. So we'll start then. Hi everyone. First of all, I'd like to, extend my thanks to Fabio and the whole committees for inviting me today and allowing me to give this keynote to you and this presentation about, as Kendra said, lessons learned from 5 years of automated software engineering for games at industrial scales. And hopefully, at the end of the presentation, I can hint you towards new and interesting research direction that could be tackled by the community. So, so we are all on the same page. Ubisoft is one of the world leader game publisher, and we are focusing on a large-scale AAA games. So those are games of a very high quality and which are very big and have the objective, at least, to gather hundreds of millions of players around the same gaming experience. Today, Ubisoft accounts for more than 18,000 employees that are scattered all over the world in 45 different offices. And this year, actually, Ubisoft is celebrating its 35th birthday. And over those 35 years of creating games, more than 500 games have been made and published by Ubisoft. And a smaller but very important department within Ubisoft is Ubisoft La Forge. Ubisoft La Forge is the research lab of Ubisoft. And today we are around 30 researchers, plus some students in PhDs and masters from all over the world. And Ubisoft La Forge is present in 4 different offices. So from west to east, we are in Toronto, in Montreal, in Bordeaux, and in China. To date, we have published 40 plus different scientific publications in various research areas, including automated software engineering. So to explain a bit what La Forge does, La Forge facilitates technical prototyping based on the most recent academic research topics. So we try to bring together the academic world with students, professors, and the industrial world with experts from Ubisoft. And we all sit together in one of our LaForge offices and to create the next breakthrough for video games and the next breakthrough, in my case, for automated software engineering applied to video games. So we are researching several areas such as animation, physics, special effects, sound, AI, UX, and creation assistance. Creation assistance is the field where automated software engineering lies on, because we aim to empower developers with automated software engineering practices, and we aim also to empower artists. So it lies into creation assistance. Interestingly, LaForge is not working alone at Ubisoft. It works with other Ubisoft departments, including the games, obviously, but more specifically with a department known as the technology group within Ubisoft. And the technology group has the mission to create services and tools that are required to make video game in the end. So the whole flow is then someone in the academic world is collaborating with LaForge to create a technical prototype that leverages the latest advancement in the field. And then this technical prototype is going to be transformed into a product by people at TG. And that product is going to be used then by our tens of thousands of employees all over the world to be able to make our games. And the kind of research we do is, as I was saying, from different areas. So here, for instance, you have a full pipeline with labial animation and text-to-speech generation in various languages. So you would only, give a text in the text format, a line in text format, and then everything is going to be generated from the sound to the facial animation. And this is some of our research. We have also, research to train deep learning agents that are able to navigate the words autonomously. And if you know a bit about how navigation is done, in video games, usually the way it works is that you have passes that are on the map that you can follow, but when you give abilities to players to jump everywhere, then your passes don't apply anymore, and you must learn to navigate in the 3D space rather than just the 2D space. So this is something we do too. And we are also working, obviously, in a lot in animations. So here what you can see is a deep learning model that learns to estimate the pauses between keyframes. So you have different frames that you must reach, and the player or the character is going to interpret and to infer what are the movements that are natural to go from one pose to another pose. And we do also, deep learning-based animation that allows you to generate natural movements while being responsive to a controller, for instance. And that's not at all what I'm doing personally. Personally, I'm on automated software engineering, and on my side, I'm looking only at the software engineering practices. So why do we need automated software engineering for games, and why do we need way more, automated software engineering for games? It's because games, as you have touched upon the different speakers and during the introduction, are becoming very complex over years. And to illustrate this, I took samples from the one sample per decade. So in 2002, Ubisoft was releasing a game called Pro Rally. And back then, if you look online at how many people are credited for that game, it took 78 people to make it. And that includes everyone, developers, artists, management, marketing, everyone, 78 people. 10 years later, to make Far Cry 3, which is a different kind of games, an open world, which is story-driven, then it took almost 2,000 people to make it. So once again, it's everyone from developers to artists to management to marketing, but still we went from 78 to 2,000 in 10 years. And if we jump another 10 years ahead and we look at one of the latest release of Ubisoft, which is Assassin's Creed Valhalla, then it took 5,700 contributors to make that game in the end. So if we add a few more sample points into how many contributors it takes to create a AAA modern games over the years, and if we focus only on the Assassin's Creed franchise and brand, you see that each generation of game, which are published, from once every 2 or 3 years, we have significantly more contributors that are required to do a game. And we went, from ASE1 to ASE2 plus 60%, ASE2 to Unity plus 144%, and then plus 22%, plus 5%, and then again plus 30% contributors. And to illustrate this, in numbers, from Far Cry 3, which was 2012, and Assassin's Creed Valhalla, which was last year, it takes about 5 times more code contributors. So if you are only looking at the developers, you need 4 times more contributors and 5 times more code contributions. In terms of lines of code, it requires about 3 times more lines of code. And the map size between Far Cry 3 and Assassin's Creed Valhalla grew by a factor of 10. And so today in video games, we are creating games that are, from country scale, hundreds of thousands of kilometers square, to continent scale, to planetary scale. And if you do that, obviously you need more and more people to be able to create those experiences. Even though you could argue that, some of those games are generated procedurally, if you want to have control over everything that is generated, it still requires a lot of engineering power and a lot of automated software engineering. So if we try to look a bit behind the curtains of making modern AAA games, back in the day, it used to be that programmers were writing C++ code, and that C++ code was doing pretty much everything. And we could, build an executable for various platforms, PS4, Xbox, PC, and so on. And we had a game which was enjoyable by our players. And this was very much the way, Pro Rally in 2002 was made. But more and more, the game pipeline is getting more complex. So you have still the C++ developers that are, creating C++ code. But in addition of this, you have a lot of specialized trades that are involved into making a video game. You have sound engineers, you have animators, you have texturers, and those people are, versioning their work into different control systems, dedicated for sound and dedicated for data. But these people, sound engineers, animators, and texturers, to do their work, they require special tools. And those special tools, some of them can be bought, some of them are open source, but most of them we do ourselves. So it means that you have another kind of programmers that are writing mostly C# code to make the tool that then the sound engineers and animators are going to be able to use to, create their work. And games nowadays are always connected, meaning that they are always connected to a game server. And in general, the game servers is built using the same assets than the game client. And this is to make sure that we have a perfect compatibility between game servers and game client. You wouldn't want to have the physics generated on the game server be different from the physics generated on the game clients because you are not using the same version and the exact same assets. So usually, we build the two executable from the exact same sets of assets. And it's still not finished because when you are, playing your modern AAA games, you want to be able to play with your friends. You want to be able to collect rewards. You want to be able to buy maybe extensions and stuff like that. So in addition of the game clients and the game servers being connected, the game clients and the game server also talks with a lot of web services that are revolving around the video game clients and servers. And those games, those web services that are providing matchmaking, stores functionality, and whatnot, themselves are written by yet another kind of programmers that are writing specialized code for this. So you have all of those different trades that must collaborate to create a modern AAA game, and this is also why it requires so many people in the end. If we look at maybe the pipeline of integrating code within the video game, the way it looks like, so we have several beginning of the stories for writing code. You can write code to fix a bug, you can write code to add a new task, or you can write code to enhance the performance of a given functionality. So depending on what you are writing for, you are going to follow different passes, but more or less, you are going to write your code change, then you are going to push your code change to the versioning system. And there we have several approaches already that are relying on recent advancements on automated software engineering in general, and for games also in particular. For instance, we are going to assess the riskiness of a change. So we are going to assess the likelihood that the given change you are about to submit or that is just landed into the master branch is going to introduce a new regression. And we are going to touch a bit on how it works later on. But we are also doing test selection. You must take into account that we have hundreds of thousands of unit tests, integration tests, stress tests that are living alongside the production code. And if you were to execute all of those tests on every code change, then you won't never reach the end of your pipelines, because it takes hours and hours to test all the tests that you need, that we have. So we have approaches to be able to do test selection with respect to a code change. Then we also do reviewer suggestions to be able to recommend which person is the more apt to review a given code change. We do missing file suggestions. So when you do C++, it's very common to have to edit the CPP file and the header file together, but it's not the only case. You can have configuration files, you can have build files, you can have data files that are somehow related to the code file you are editing, and we are learning from what are the patterns of co-edition within files. So when you are submitting something, we can maybe recommend a file that might have been forgotten. And then within the code review, we have humans that are reading the code and suggesting changes to the code, but we have also machines that are suggesting patches directly to the developers, and that are trying some of those patches autonomously by landing a patch directly into the CI and see what's going to happen. So the machine suggested patches, some of them are rules that we can just apply. You can imagine a rule written by a senior software engineer somewhere. If you see X, then transform X into X prime and then commit it like this. It could be as simple as just code style, but sometimes it's a bit more involved, where you want to actually transform expressions from X to X prime. But we have also patches that are suggested on what we learn are, codes that are introducing either a stability regression or performance regression from our 35 years of code history. So we can, recommend changes to developer. But this is the flow only for developers, right? Only if you are a software engineer. But while what we were saying before is that it requires a lot more than software engineer to be able to make a AAA game. So you have similar, flows that are alongside the developer's flow. For instance, if you do a 3D assets or if you do an animation tree, you are going to be also working for different tasks, bug fixing, adding a new features, performance optimization. And then once again, we are going to be able to support you within the CI to be able to predict, again, the riskiness of a change, to do reviewer suggestion for an assets, because assets, be it 3D assets or animation, they are reviewed the same way code is. And then we can also suggest patches to be able to improve a given asset. And we do, once again, the same thing for sound. So as a sound engineers, you are, submitting your sound is going to get reviewed, and then you can have suggestions on your sound that are automated or that are, provided by other sound engineers within the company. So you have these three, CI pipelines working alongside one another. But if you want to make your game in the end, if you want to have your executable that is able to, being played by users, you need to combine those three CI pipelines. And this combination then allows you to produce executable that make the game in the end. And, it's the multiplication today of gaming platforms make this very complex. And it's a very good opportunity to re-explore maybe what has been done in CI configuration and in build configuration over the years in the classical automated software engineering literature, because those three pipelines are going to be combined and optimized for PlayStation 4, 5, for Xbox One, Xbox Series X, S, for Switch, for PC. And then if you follow closely, maybe the gaming world, you see that we have some problems today with Windows 11 because of the way the new, CPU schedulers is working with high efficiency and low efficiency cores on Windows 11. So it creates problems. And if it does create problems, it means that we need to fix them in the way we are generating our executable. So it brings us back, to the pipeline itself. Then you have the mobile world with iOS and Android. Then you tend, to use most of the code and most of the assets when you switch from platforms, because you want your players to have the same experience from platform to platforms. And after the consoles, the PC and the mobiles, then you have cloud gaming that you must account for. So, you must build for Stadia, you must build for Amazon Luna, for Microsoft xCloud, and for our own game servers that we are going to build. So all of these game servers and cloud gaming builds, you need to deploy them all over the world, so your clients are able to enjoy, latency-free gaming experience. So to do so, we are collaborating with all the cloud vendors out there. So Microsoft Azure, Amazon, Google Cloud, and we are also, operating our own private data centers for some of our games and for some of our services. And once again, you have there an opportunity to do some serious research and, re-explore what has been done before, because you have a latency criticality, you have multi-cloud concerns that are getting in there. So as a player, in the end, you can finally, after all of this, start to play and start to enjoy your game, because you are able to, download the game client from one of our servers, and you are able to, start game sessions. That game session is going to be shared with other players all over the world. that are, you know, contributing to this shared experience that you are enjoying. And this is, you know, the game session itself, but more interestingly for us today in the context of automated software engineering, those clients are sending back telemetry information that are, you know, traveling through our different cloud providers and that are getting back to us in forms of performance telemetry, gameplay telemetry, error telemetry, and also the shop telemetry. And you must, you know, realize that this telemetry that is sent back by our hundreds of millions of players represents trillions of data points and hundreds of terabytes of data per month. So if you want to be able to, you know, make sense of it all, you need to have serious, you know, assumptions and be able to test them out pretty early on in your development if you want to be able to take action on them. And as I was saying, in this whole pipeline and all the complexity that it takes to have everything, we have opportunities for breakthrough supported by you know, automated software engineering for games everywhere in this cycle. From CI of code, of data, of sound, to building and optimizing for such a wide range of platforms, to continuously delivering new builds everywhere in the world, and auto-scaling the game servers as required. So, and then this is one flow, but we can also look at supporting developers, artists, and sound designers directly in their workflows, using, you know, machine learning and AI for instance, suggesting, you know, patches and distilling recommendation directly into their IDEs and directly into digital creation tools. And we were just, you know, discussing about telemetry, but this telemetry that is going on and that is reaching our servers, that is representing, you know, trillions of data points each month. There is also huge opportunities there to have to create new breakthroughs dedicated for you know, video games. And along the years, we have been investing in all of those different areas. So from year 1 to year 5, we have been investing mostly into the, you know, the code development aspects and what it takes to create codes and to build codes and to deploy the code aspects of our games. And from year 3 to 5, we've been investing more into, you know, the auto-scaling of game servers, the distribution of game servers. And in year 4 and 5, we've been investing also in analyzing the telemetry that is getting back to us, so we can make sense of it and then build recommendations that we can integrate directly into the IDEs of our developers and the digital creation tools of our artists. And finally, year 5 this year, we are starting to investigate a bit more what can be done and what kind of breakthrough we can achieve into the data you know, creation, the data CIs, and the sound creation and the sound CIs. All of this leads to publication, even though our first objective is not publishing, but, you know, creating breakthroughs that are applicable to video game creation. We still like to publish and to be able to, you know, share all of our findings with the community. So we have, you know, publications and keynote on various aspects. But to me, more interestingly, those papers, those keynotes that are contributing, you know, to the community, they are transformed into usable tools that people are able to use directly within the video game creation pipelines. And it goes back to what I was saying at the very beginning, is that you have La Forge, which is the research lab that is dedicated to create technical prototype based on the latest academic progress. But then those prototypes are not, you know, taking dust or laying on the shelf somewhere. They are industrialized and transformed into products by the technology group that is collaborating with La Forge. And then all of these efforts, we can ask ourselves, you know, does it have an impact, or what is the impact of everything that we are working towards with respect to automated software engineering for video games. So we did a small, study where we could have a proper A/B test of people using the approach that tries to detect if a given code contribution is going to introduce a defect, and people that were not using this approach during the creation of one of our AAA game. And we found that using those approach at scale provided us with a 36% reduction in bug introduction rate. So we started at 90%, which is very much aligned with what you can find in big open source systems. And we dropped all the way to 12%. And it came also with some additional benefits, such as the experience of the selected reviewers and the reduction of the number of lines of code. So all of those numbers obviously are to be, taking with a bit of a warning, because there is a lot of stuff that is happening on the CI pipeline. So while we are doing our A/B testing, maybe the CI is getting a bit more robust, and there is more tests that are written, and the QA people are getting more experience. But still, all in all, we find a very interesting, productivity uplift and bug reduction, bug introduction rate reduction within our pipelines when we apply these techniques. So if we interest ourselves maybe on some of the details of the research that we are doing at La Forge with respect to, once again, automated software engineering for games, we are building a lot of tools now on what has been done by the community on just-in-time bug introduction prevention, where you are learning from code commits, and you try to understand using the SZZ algorithm what code commits are buggy code commits and what code commits are fixing code commits, so you can learn what makes a bug in a way and what makes a fix. And you can then extract features about all of those code commits dedicated to video games and understand what makes a buggy change in video games and what makes a fixing change in video games. And the way it works is that you are analyzing the code contribution themselves to see what changed between a revision and another one. And you are looking inside the abstract syntax tree of what has been modified, and oftentimes you see that you have lines added, line removed, loops that are added, conditional branches that are added, and so on and so on. And if you look at it from the abstract syntax tree, you can have nice, branches of the tree that are modified, and you can extract those changes into what we call, script changes. And all of those script changes are, usable then to provide patch recommendation that we can suggest to our developers. So the way it works is that from a code change, you are extracting the AST that has changed. You are extracting the difference between the tree before and the tree after, and you are extracting what needs to be modified from one tree to go to the other tree. And you learn all of these patterns of tree modification within the abstract syntax tree. And when you see something that looks like a buggy pattern that you learned from the past, you can try to apply the transformation that you have applied in the past to go from the buggy tree to the to the stable tree. And it gives you another, edit script that you can apply directly into the code. And within the IDE of the developer, you can suggest all of those modifications from within Visual Studio. We are also working a lot on auto test selection. As I was saying earlier, if we were to run all of our tests on all of our code commits, we would spend, centuries of CPU time for each and every months of game production. So we try to find smart ways of selecting which test to run and when to run a given set of tests. So to do so, we are looking at, once again, the ASTs, but also at the control flow graphs between, the test code and the code under test. And we are computing reachability between the test code and the code under test. So when a piece of code is changing, we can follow our reachability analysis from the test code and see which test is going to cover which piece of code using static reachability analysis. And we are going to then run those tests first. But even doing this and even computing static reachability between test code and production code is not enough of a reduction. So we need to go a bit further, and what we do is that we have classifiers on the set of tests that are potentially covering a piece of code that has changed to be able to decide in the tests that are likely covering the code that has changed, which one should I run first to be able to have a first failure as soon as possible, because the whole game here is to be able to have the pipeline failing as soon as possible, so the developer can take action as soon as possible, or a machine can try to suggest, a fixing patch as soon as possible. Interestingly, and that's something also that might be, a novelty for some of the communities, that we are doing a lot of work on manual test recommendation. So you must, understand that we have a lot of manual testers within our company, and that when we saw, that it requires a lot, almost 6,000 people to make Assassin's Creed, nowadays there is a significant chunk of these that are manual testers. And the goal of automated software engineering is not to, let all of those people go, not at all. It's to focus their effort on tasks that are more suited to human discovery and more suited to a human, driving the show, because you want your human testers to be able to assess stuff that are a bit more, abstract, such as, is the game fun to play? Is the graphics, fun, pretty to look at, like we saw in one of the papers that was presented today? And you don't want your testers to be testing, does the game, do what is supposed to be done? So the way we do manual test recommendation is that we are building a relationship between a piece of code within the game and a high-level feature that might be experienced by a gamer somewhere. And then we can suggest to the manual testers, maybe you should go and play with that given feature for that new game build, because that feature changed, and the way the players are going to experience that feature is now different than it was before. And to give you an example, from a given code commit, you are able to suggest to the manual testers, okay, what you should do is try to go in the store and try to see if you have overlapping in the text, try to see if you can buy such and such items. Maybe you could try to do, a game against such and such opponent to see if it reacts properly. We are also working a lot in game server auto-scaling. And the thing with game server auto-scaling is that, and I will also touch a bit on this later on in my keynote, but game servers are a weird beast that is not well understood by the community, in the sense that it's a long-lived process that is stateful, and the states are shared between a lot of different clients that are connected directly to it using, TCP sockets and whatnot. And the load of game servers around, the different, hours of the day is not as predictable as you might think. And so you cannot just apply, rule based on scaling your game servers, because it really depends on a whole ecosystem that we have not 100% the control over. For instance, you could have one of our third parties, selling our games, doing a promotion for 1 hour, 12 hours, 24 hours, and they are not telling us about this. But this is going to create a spike in traffic, so it's spike in game servers, requirements. You could have one of our competitors having, problems with their own game servers. So the people that were playing our competitors' games are going to, shift towards our game, and the reverse is true also. Obviously, you can have, problems with the PlayStation stores or the Windows stores, and then people can't play anymore. So you have less demand than what you were expecting. So all of this, creates a lot of variability within game server, and get the approaches that we have today in server auto-scaling are not working for us. So that's why we are investing a lot in this. We are also working a lot in, language agnostic brown build detection. So where we are, flakiness in your test. So you have your test, and the test is going from red to green without the code itself changing. So you're just, rerunning the test, and the test is going from red to green. And most of the approach that we could find in the literature are not specific enough for video games. And because video games are, as I was illustrating earlier, the combination of many different pipelines, many different programming languages, and you need to have a brown build detection system that is language agnostic and pipeline agnostic, so you can, do accurate brown build detection without being tied to a specific SDK, without being tied to a specific programming language. And we have also, we are investing also in different and other areas, such as the impact of cycling development on the software engineering literature. So, if you are following all of the papers that are, almost all of the papers that are published into patch generation or into, software maintenance and evolution, one of the citation we like to use, and myself also, is the citation from, the split between the research and development and the software maintenance and evolution. And we often say that software maintenance and evolution can account for up to 70% of the total development cost of a system. But and it used to be true for classical video games. So in the 2000s, it used to be true. But 2 decades later, it's less true, because we have, a lot of the games that are produced for periods of 3, 4, 5 years in isolation, and then the development cycle shifts completely, because you want to be releasing new contents for your games and new features for your games and new way to play the games every 3 months. And this, breaks the cycle that we know for software engineering and that we used to know. And what we found is that most of the software engineering literature with respect to software maintenance and evolution doesn't apply directly when you are into those cyclic development cycle for video games. We are working also a lot on performance regression, detection, and clustering. So when you have a performance regression, is it a performance regression that you know? Is it a performance regression that already happened somewhere or not? We are working on just-in-time performance evaluation. So in the same way as we can do, code change recommendation directly into your IDE that are targeting code stability, we are nowadays trying to do a code change recommendation directly into your IDEs that are targeting performance changes. So, okay, maybe don't do this piece of code like this. While keeping the same behavior, we can propose you this piece of code that has a faster execution time, or maybe a lower memory footprint. We are looking into incident detection and prediction. It could be hardware incidents, it could be software incidents. We are looking also in outlier detection in online games. So for instance, if you are looking at the matchmaking success rate of a given game, and you see 99.9% success rate, meaning 99.9% of all of our gamers are successfully finding a games to play. But if you are able to do accurate outlier detection, you could discover that the 0.01% or the 0.1% of the people that can't play all share the same hardware, or they all share the same ISP, or they all share something in common. And so if you are able to do outlier detection at scale and with accuracy, it means that you could identify entire subset of the population that are not able to play at all because they are otherwise hidden into the mass of players. We are also trying to assess a video game characteristic from the empirical software engineering standpoint. So when you want to do empirical software engineering research, what does it mean for video games? And once again, we have seen some example of this just before me with the metrics and the definition of the metrics and the impact of the metrics that the metrics can have on maybe game designers. We're also looking into software artifacts embedding. So it's very well known how you should embed natural language. And it's very well known how you should embed an image, or even nowadays a video. But when we are talking about an AST, a control flow graph, or when we are talking about a 3D asset, a texture, those are rich elements. Those are rich software engineering artifacts that are, some of them are dedicated to video games, but not all of them. And embedding those to be able to have a nice representation that is going to generalize fast enough and going to give you models that are, high accuracy, performance, and whatnot, is not something that is yet agreed upon in the community. And so this is something we are researching also on our side. And we do also rich context-aware auto-completion in our game. So, you are working on a given Jira, and then you have this and this open issues on the side that are assigned to you, and the piece of code where you are, is all of this is the context that we call rich context, and we are, applying auto completion that are powered by a deep learning algorithm to be able to leverage all of this context in addition of just, the line of code that is above you and the line of code that is beneath you. So to come back then to the title of this talk and what we learned from doing all of this research over the 5 years, over the last 5 years, the first thing is that as I was presenting earlier, we began and focused a lot on software engineers, and it comes also from our respective backgrounds where we are software engineers and we do automated software engineering. So naturally we target first software engineers, but what we learn along the way is that all of the crafts that are required to build modern AAA games can benefit in some way of automated software engineering approach. So you can think of QA testers, you can think of artists, sound designers, but also build masters, live operations specialists, and even the players themselves. Because if you are able to do or to create approaches that act upon the outliers we were speaking about just before, where you can say to a player, okay, the game doesn't work for you because you have X, Y, Z that are activated on your system, or you have a problem with your ISP, or you have a problem with your graphical driver, then the player themselves, using what we have been building as approaches, can fix the game for themselves in a way and be able to enjoy the game and play it. but when it does comes to software engineering, and then when you try to do, those approaches that are applied to software engineering, we found that you have only one chance to make a good impression, and that false positive are your worst enemy, or false, and they are way more impactful than false negative. So it's very much okay to miss a classification, to let bugs through, to let a regression through, than to create a false alarm, than to create a false positive, because the building trust in that kind of environment is the hardest thing to do, and you want to be able to keep that trust over time, and false positives are impacting that trust way more than false negative. And we found also, when it comes to those kind of approaches for software engineering, that explainable AI and everything that you can do with Shapley values and the way you can explain how a classical model works and how a deep learning model works, in the end, it doesn't help the software engineer to understand the decision of the model. It doesn't help, the software engineering to see why a given recommendation has been processed the way it has. It really helps the data scientist behind the model to see if the model is performing as expected and if the model is following expectation. But when it comes to understand what the model does, what we have today in the explainable AI fields for those kind of approaches related to software engineering is not enough, and it doesn't translate well to classical software engineers. We found also that you need to keep traceability for everything. So every prediction that you do, every recommendation that you do, you need to keep track of it. You need to keep, your input vectors. You need to keep logs of your inference. You need to keep the model that was used. You need to keep the data that was used to train the model, and you keep everything to be able to afterwards create feedback loops with your users, because you have those users, tens of thousands of developers and artists that are using those models day in, day out. And you have the opportunity to ask them for their input on this. So if you don't, with the traceability, you can ask them, okay, is this a good recommendation? Is it a bad recommendation? And they provide you this feedback. And if you combine the feedbacks of the users with the traceability of everything, you can improve your model again by training them to reach high level of recommendation that are going to be accepted by developers or artists. We learned also that very small gains could and have very high impacts, and this scales linearly with the number of people that you need to create a game. Because while in maybe the scientific literature, improving something by 0.1% of 0.5% would be seen as not very novel and not very worth publishing maybe. In our reality, while we are doing this kind of research, 1% improvement means a lot, because 1% improvement is saving 1% of the time of thousands of people, and those thousands of people can then focus on the next feature, can then focus on the next game. So even very small gains into what automated software engineering can bring are multiplied by the number of people we have working on the games in the end. And another thing which we learned the hard way is that old habits die hard. And when at the very beginning of the presentation I was saying that we have nowadays more than 18,000 employees, and collectively over the last 35 years they have produced more than 500 games. So there is a lot of change management to be done when you are trying to do this research and have this research used into video game creation, because well, they have produced successfully 500 games so far. So if you want to change the way things are done, you need a very good reason to do so. And change management around the way we are producing software is not something that is very much, explored into the scientific literature, and that's something we could also all together contribute to. So that leads us then to what are my hopes for automated software engineering for games, future research directions, and what I would like the community to research upon, and where ourselves are going to be in the next 5 years of research. So first, there is a lot of research to be done into cloud gaming aspects. So when we are talking about cloud gaming, we want to be talking about game engines that are natively made for the cloud. So it's not the same old engine that we had before that you put on a virtual machine somewhere in Amazon. You want to have dedicated game engine that are leveraging natively what the cloud can bring to the table. And you have this very nice book, which is titled Game Engine Architecture, which is the Bible of game engine architecture. It teaches all you need to know about classical game engine architecture. And when you look at the picture that is inside the book, you have all of those different pieces that all together combined makes a game engine. And when you look at this, we should investigate as a community what should be done differently when we are talking about non-native, what should be transformed into microservices, what should be transformed into something else, what should be still running on the client side, what should be only running on the server side, and while taking into account all the specificities of the video game domain, such as the latency, the video streaming aspect, the multiplayer aspect, and so on, because if you take that monolith today, which is a classical game engine, and you try to apply on it the literature that has been published to transform monolith infrastructure or monolith software to microservices, it doesn't work, because those approaches are not taking into account the specificities of a video game in the end. We talked a bit about that before, but on game servers themselves, the game servers are not well understood and not well explored into the literature, because they are very different from the cloud compute that you can use, and very different from the kind of compute that is investigated in the literature, in the sense that they are very long-lived, they are stateful, they are very slow to boot. So when you request a new game server to Amazon, it can take 30 minutes up to 1 hour for that game servers to be available. They are multi-cloud, so within your game session, you could be sharing some state with a player that is playing from Australia, and while you are playing from Canada. And in Australia, we don't have a good coverage for a given cloud provider, and in Canada, we don't have a good coverage for another game cloud provider. So they are not even going to play using the same cloud provider in the end. So this is something also the multi-cloud aspect, which is very important for game servers. And game servers are unfortunately very subject to different kind of attacks, such as DDoS, because as I was saying before, when you are playing, your game client is tightly synchronized with your game servers, and so it's not an HTTP communication that you have there that you can hide behind load balancers and stuff like that. You are directly connected to your game servers, and this opens up vector attacks that we must also take into account when we are scheduling game servers all over the world. And when it comes to empirical software engineering, nowadays the trend, at least in the last few years, was to not only analyze a few dozen software engineering projects, but analyze ecosystems of projects. So you are going to analyze all the Apache ecosystems, all the Apache softwares, and then you are going to analyze all the Eclipse softwares, and you are going to analyze all the NetBeans systems, for instance. But the thing is that if you do it this way for the 500 games we have, for instance, your hypothesis won't hold ever, because the way games are produced over the years is evolving too fast. From generation to generation, the way we are creating games, so from the PlayStation 4 to the PlayStation 5, is going to change. And this drastic change in the way we are producing games, doesn't allow you to have nice p-values that are under 5 and that you can, publish in the end, because everything is changing everywhere and you don't have this, easily, you can extract easily those statistics. And even within a generation of consoles, the console itself is going to be, modified by the console vendors. So over time, Microsoft, Sony, and so on are going to allow us as game developers to use more and more of the hardware of the consoles over time. So even within a generation, for the same title, for the same game, the way we are producing it is going to change for a single console. So, if you are going to try to do some kind of empirical software analysis where you want to have p-values everywhere, and you try to have to encompass 35 years of game development and 500 games, it won't help you validate what are good patterns, good anti-patterns. Sorry, that's my camera there. For your video games, it won't help you validate what are video game smells or what are video games bug taxonomy. So in this fast-paced way of creating software engineering and software engineering artifacts, we need a different way to do empirical software engineering if we want to have some meaningful results there. On patch recommendation, it's very interesting that there is a lot of work, including in ASE, that is published into how to automatically identify regression, how to automatically patch a regression. But what I find, and it's still related to this space that we have in software engineering for video games, that those approaches are always considering bad code as bad forever and good code as good forever, in the sense that they learn once what is a regression, and they are going to feed you the same recommendation every time they see that something looking like it. And the same for autocomplete approach, such as GitHub Autopilot, the more time you see something, the more you are going to recommend it. But if the underlying ecosystem beneath you is changing every 6 months, then you cannot rely on the fact that bad code is going to be bad forever and good code is going to be good forever, because the way we are producing code is evolving very, very fast. And so patch recommendation aspects should be investigated by the community, as included, in this specific environment. So we can also think about tests, and what does it mean to be test-driven when the feature and the test itself constantly evolve. And we have seen a nice talk at the very beginning today on testing and using the videos that the game is producing to be able to perform some automated tests. But if you have this given feature, let's say that the feature is to leap over some fence, and then that feature that is called oftentimes vaulting in video game, where you vault over something, it's a very tricky feature to implement, because to vault over an obstacle in a natural way, it requires a lot of different point of collision with your hands, with your legs, and then maybe you do a wall when you jump over the fence, and so on and so on. And you have this very complex feature that is going to create an equally complex test to be able to automatically test this feature. Are the collision between your hands and every type of fence perfect? Is the wall going 100%? Are you having the right kind of acceleration of your character models, and so on and so on? But you have this complex test testing this complex feature, but then you have things that the test cannot test automatically, such as the naturalness of the vaulting above the fence. And so you will have a human tester saying, okay, I'm going to reject your vaulting feature because it's not looking natural enough. So you have all of this investment that has been done into testing this complex feature that you can almost throw away because you are going to evolve a lot the feature itself, so the feature looks and feel more natural. So it's a hard balance to find into when you should write tests with respect to where your feature is at and what is the actual return on investment of your test. Because when you found the naturalness and you found the fun in your features and the testers are validated that this is the way it looks like, in a way it's tested forever because if it's fun, it's not going to evolve anymore, and writing a test for it could be seen as a waste of time. And there is also the interesting aspect about combining different type of tests. So when we say automated tests, we tend to jump into unit tests, but as it was presented today again, there are many more types of tests that can be done. Graphical tests, of course, for video games, but also system test, integration test. Then you can think about a deep learning exploration of the world. You can think about human exploration of the world. And maybe we should, collectively try to design approaches that are suggesting which proportion of which kind of test are the more beneficial for a given feature or for a given set of features. On explainable AI, also some future research direction, and we were hinting at this just prior, but the sharp values and the way it works, it really, in my point of view at least, helps the designer of the systems and helps the data scientists that have created the models to understand if the model is doing what is supposed to do, and if the assumption you had when you built the model are true in the end. But it doesn't help really the software developer being exposed to the model recommendation to understand what should I do about this. Is it something that is game breaking and I should fix it, and if so, how should I fix it, and so on and so on. It's really it needs to evolve a bit, and I think the way or the direction we must look at is try to define causal features for video game and for automated software engineering for video games, because today the features we have are more catching on correlation than causation. You are looking at the number of lines added, you are looking at the number of lines deleted, you are looking at the cyclomatic complexity, you are looking at the memory consumption difference between version A and B, the runtime, the execution time difference between A and B. And all of these are catching on clues and trying to build correlation between those features and possible regression and the possible action that should be taken, but they are not building on the causation itself. And I think if we can collectively define causal features that are aiming for just-in-time performance regression, just-in-time defect prediction, and then apply maybe sharp values on those causal features, we could have a better, we could be in a better place for software engineers to understand what should be done about a given recommendation. On bug triage, also some future research direction that could be interesting to explore together is that, we have a lot of papers and approaches that are, effort aware. So I'm going to suggest you to tackle a given bug because the effort for fixing that given bug is, above or below a given metric, because we think that we are going to require less than X lines of code to be able to fix it. But, we should also be able to put into the balance not only the effort it's going to take to fix a given bug, but what is it going to bring to the players? Is it an easy bug that is, impacting 1% of the players, one case over 1 million? Or is it a bug that is maybe a bit harder to fix, but is impacting a wide range of the players community? So with all of the telemetry that we are getting back in terms of performance, in terms of stability from our game clients, this is something that we could investigate. What is the best balance between, bug fixing effort and bug fixing, benefits for players in the end? And we could also look at what kind of bugs impact different aspects of a video game, in terms of player experience, in terms of sales, in terms of brand fidelity. Do you have some kind of graphical bugs that are destroying the player experience, but not impacting that much the brand fidelity? Do you have kind of bugs that are, hindering heavily your sales, but not that much, the player experience, and so on and so on. And with respect to observability, again, we are today in a world where we want to be, building video games that are taking into account the privacy of our players by design. But, this being said, what kind of things could we observe within our game clients, within our game servers, within our CIs, while keeping the privacy of everyone in mind, that allows you to create a positive feedback loop in the way you are creating games? So if we are able to make the hypothesis that adding a given point of collection at the very beginning of the pipe is going to cost thousands of dollars to deploy it and to operate it and to collect the data and to clean the data, but might allow you to do X, Y, Z 10% faster, then it's a discussion we can have and discussion we should have. What are the observability points that within the creation of video games you should have, because those observability points allows you to create better video games in the end. And we can also, think about more meta work, in a sense, about, work organization itself. As we were, saying a few times already, to create Assassin's Creed Valhalla, one of the latest, Ubisoft release, it took 5,000 people, almost 6,000 people from 17 different studios, so scattered all over the world. And how should we work to automatically, but how should we work to better sustain this? Because this is a trend that is going to continue to grow. We went from closed game where you experience a car on the track, which is known, to a game which is a city, to a game which is a country, a continent, a planet. And so it's going to take more and more people, even though we are trying to optimize, the way video games are produced. The way video games are scaling, and the fact that the teams are distributed geographically, there is something that we could, investigate also in that area. And it could be interesting to discover or rediscover the way we are currently self-organizing with respect to the numbers of contributors and the numbers of studios, by data mining all the different assets that we have in our repositories and in our code repositories, data repositories, and sound repositories, to see what are the collaboration and the ad hoc ways that we are working distributed like this. So this brings us to the end of what I had to share today. As I was saying, we are publishing as often as we can in scientific venues, so we can find a lot of our graphical work into SIGGRAPH, which is graphical conference. We also published at NeurIPS, SEMLA. The GTC is a very valuable piece of information. So it stands for Game Developer Conference, and it's not a scientific conference; it's a practitioner conference where all of the different game publishers and game developers from all over the world are sharing advancements on what they have done. And from my experience, there are, most of what is shared on the technical tracks of the GDC could be, presented also into scientific venues, because they are making scientific advancements on the way we are creating video games. We published also at MSR and ASE. We have a corporate website, which is laforge.ubisoft.com, that where we publish some blogs and articles on what we are doing and the events that are happening. And you can also find me on Twitter, where I try to share also everything that we do. Of course, I have to take the opportunity to say that we are hiring in those different fields. So you can follow the two links that I've put there, work at Laforge or work at TG. So once again, Laforge is the research lab that is driving the technical prototyping. And the TG is taking the technical prototypes and putting them into the hands of our developers by creating products that are the industrialization of those prototypes. We have some exciting roles that are currently open, such as an R&D scientist specifically dedicated to automated software engineering and software development. We have also several roles for R&D programmers and machine learning programmers. And that concludes all I had to say for today. So I thank you once again for the invitation and for listening to me today. If you have questions, I'll be happy to answer them now.
Well, thank you so much, Mathieu, because, wow, after listening a lot of opportunities that you have, that's why you are here, just to listen. How can you help the community, help the industry? And when you said 1% is a lot, I say, yes, you have a lot of work to do, and I really, really appreciate. Thank you so much. So Kendra have to just to stay out a little bit. She will come back for closing. But now we are open our for questions and our discussion. I think you have a lot of topics to discuss, and you have some questions from from Antonio and Shane. Maybe Antonio, could you share your question with Mathieu?
Yeah. Thanks a lot for this great presentation. So I know Ubisoft, and I know that you are very active in games development from a long time. But my curiosity is, do you have in your company, in your research group, some direction on serious games, not entertainment games?
Mm-hmm.
Because I'm working a lot in the last years in gameful systems where the goal is to incentivize people to change their behavior or to educate people in different contexts. So do you have in mind some research direction or development direction in this field?
So we try often to branch out outside of video games, research for video games creation. So we have, recently we've been publishing GANs, so networks that can generate whatever you want them to generate to simulate the impact of climate change in various cities all over the world. And we are using our game engine to do that because the game engine are realistic enough that it feels like it's a real place, and then the game engine is flexible enough that you can add waters, you can add tornadoes, you can add whatever you want. And so this is one area where we focus maybe on research using our engine or know-hows, but for something else than video games. We are also doing, some works on education and how, video game engine can be used to foster, some new skills that you want people to learn. So these are some areas that we are investigating. However, I'm not the one investigating them. It would be, some other scientists within our research groups in Toronto, in Montreal, in Bordeaux, and in China.
Okay, so thanks a lot.
Sure.
You have also another question from Shane.
Hey, Matthew, how are you?
Hi, what about you?
I'm okay. So I was just wondering about your test selection approach. So you're relying on like static information, if I
Yep.
understand correctly. And I was just curious, like, are dynamic features not used in games very often, or is that like
Yeah.
a pain point for you?
You try to avoid the dynamisms as much as possible because it leads to unforeseen consequences, often with respect of allocation. So when you do dynamic injection, it means behind the curtains that you have a dynamic allocation of something. And this is one of the worst things you could do in video game, because you want to control very precisely how many bytes of memory you are going to use and how many bytes of GPU memory you are going to use. So dynamic allocation is something that is very rare when you are talking about game engine and game client, and most of it is statically allocated and statically discoverable to improve on performance. And it makes code very hard to debug and very hard to evolve and very hard to maintain. And this is something that we have to do. But yes, it's there is not so much dynamic ingestion and stuff like that.
Okay. Yeah. So it's like a static analyzer's dream.
Yeah, a bit. You can think when you are in the game and you have this cone of visibility in front of you, you have all of these objects. It could be whatever, the wind, the wildlife, and the flora and whatnot, that needs to be updated at each and every second, and more than one times a second, obviously. And all of these objects, you can think of them as just being baked into one bigger array of object, and then you are going to traverse the array of object and just say apply on each of the different objects, so you can discover them and refresh them pretty easily, and you cannot have something which comes out of nowhere that has been dynamically allocated, because you could exceed the budget you have on your video card, you could exceed the budget you have on your video on your system memory, and the game would crash.
Okay, thanks.
Great. Cristiano, go ahead. And
I have a quick question. Thank you for the presentation. Very interesting. Many things I took note here. But one caught my attention when you talk about the testing, and it took a long time to test, and you cannot test you cannot like run every test when you make a small change in your code. Therefore, you have that tool that helps you. That scared me a little bit, because my thesis is on testing, and
Sorry.
for that.
Scared me, because my plan is like putting a little bit more of overhead, so maybe I need to check my plan. Anyway, my question is, do you think there is still space for end-to-end testing?
Yes, obviously. The thing is, when you are looking at Assassin's Creed, Watchdog, you are looking at, if you are only doing the main quests and the main story within the game, you are looking at 50 to 60 hours of gameplay. So you have hundreds of programmers working on the game. They are all submitting, something every day, let's say. So you have this, you cannot do possibly end-to-end testing or even unit testing for these 60 hours of gameplay for each code change, because it doesn't scale. Even if you want to throw money at the problem, there is some point where you just can't allocate enough, virtual machine and game servers to run your test. So I think we still need to be able to run end-to-end tests, and the very interesting way and approach is to select the one that are the most likely to yield something, and to yield something the fastest, because you want to be able to create an iteration loop with your developers where you have a result from your CIs as soon as possible. Because once again, let's say you have those 50 hours of gameplay, and that translates into maybe 200 hours of testing end-to-end. As a developer, I'm changing an if condition somewhere. I don't want to have to wait for 200 hours for my if condition to be good enough and validated enough to land into master, because otherwise it won't never land, So I need to be able to have focused testing that is run on my change, that completes fast, that gives me good enough results as fast as possible. And then obviously when you are nearing, a release, then you are going to run everything but once, not on, each and every code changes. And then, to conclude or to continue on this point, another thing that we are working on, and that we are very much, a hard time solving nowadays, is that you do this end-to-end testing of everything at the end, when you have, a build that you might publish to your players, so once a week or something like that. But then in a week, you have thousands of code patches that have been submitted, and said, this end-to-end testing fails. Then you want to be able to track back, why did it fail? And you want to be able to, warn the developer that might be the one responsible for this failure, that something has to be fixed. But once you have, thousands of patches to go through, it's not that trivial anymore, because, what you have written could have been modified twice or 3 times already before that test is run. So identifying which patch is the faulty one is very challenging, and you cannot do it by classical bisection, because, once again, if you do bisection and you just, split in the middle and run before, run after, it takes hundreds of hours of tests for each bisection, and you don't have that kind of time to wait.
Got it. I think I have some work to do now. Thank you very much.
Yeah, absolutely. So we are here just as an open room. If you would like to share or discuss or propose some questions or propose new directions to collaborate. And Mathieu proposed to us several topics and insightful ideas to research. After that, Mathieu, I think you need 100 of students to do a lot of.
That's the idea of.
Absolutely, I ask you to do that, Mathieu. Share with us your vision for the future. Wow, it's a lot of future for us.
And there is it's an old industry that recreating video games. Ubisoft wasn't the first video game producers and publisher.
Sure.
It has been 35 years already, and hundreds of games. So it's an old industry that resisted for a long time to embrace modern software engineering approaches, because the limitation inherent to video game were said to be too complex. Allocation, performance, graphical programming, and so on. But nowadays, we reached a point where it doesn't scale anymore, where you need so much people to be able to put your game out of the door that this change cannot wait. And the unfortunate truth is that if you just try to take what has been published in ASE for the last decade and apply it to video game, it doesn't work, because of the inherent specificities of video games. So, and this is the case for this workshop and for us being here today, is that we need to have, in my point of view, a lane of research that is, software engineering, automated software engineering, yes, but with a salt of video games in there to be able to take into account all of those specificities.
Absolutely. And also I see your numbers about 78 contributors. After that, thousands and thousands. After that, you need China to create the next China population to create the next video game.
You know, it doesn't. If you look at the size of the maps and the amount of features, it's going to require exponential amount of developers and artists in the end. And this is why also, you know, automation is not a choice anymore. You have to be able to have automated process of quality to help you out, because, you know, you cannot hire, you know, 200,000 people just to make one game. And if, you know, we acknowledge that the gaming industry is going, you know, towards bigger and bigger games that have more contents being added day in, day out, then you need ways to, you know, support your creators and to make them more efficient, more productive, and not, you know, killing them at work or hiring 200,000 people.
Just to add to that, we're not gonna we separate some news to talk about during the discussion, but you end up mentioning it anyway. This thing about scope. I would mention that the former PlayStation executive, he made an interview and he said that it's the cost of AAA video games are doubling each generation, right? And for PS5, for example, he said it's going to cost around 200 million at least. So there is like almost like a Moore's law of money, and I don't know how it's going to be in the future.
It's getting more and more complex to create video games, and because of the scales, but because also what revolves around it. Because if we were to create, you know, a Pro Rally of 2002, but we were to have, you know, thousands and thousands of races to our track to race on, it won't require as much people to make it than an open world systemic video game that anyone can enjoy, such as Far Cry 3 or Assassin, because it's different kind of games that people are expecting now, and these different kind of games are harder to produce. And, you know, when you go from the controlled environment where there is a track and everything besides the track, you know, it doesn't need to look so good, or it doesn't interact with you, and so on and so on, where you have a world that you can basically explore without limitation, you know, it's not a question of scale, it's just different. It's a different trade that you are trying to acquire. And this doesn't scale linearly at all. And when you are saying about a Moore's law, you know, for video game producing, it looks from my chair at least even more exponential than just, you know, linear. So.
Yeah, even more. Yeah.
Got a time for an architecture question. I'd appreciate it.
Yeah, one point, but when you talk about cloud gaming, for me it's a super important topic, but it's a little bit tricky for a game industry, because in one hand you have to produce aligned to cloud providers sometimes, or the infrastructure, and how to match this different platforms is super tricky, huh?
You know, we are producing games for specialized hardwares for the longest times, you know, for PlayStations, for Nintendos, for Microsoft, and so on. But everyone has the same, so it's more or less easy, because, you know, you developed it once for the PlayStation, for the Xbox, you know it's going to work for every PlayStation and every Xbox is out there.
Yeah.
And at the beginning, you know, it was kind of, you know, understood that cloud gaming is going to be just, you know, another platform to develop for. You are going to develop once for Stadia, you are going to develop once for Luna, you are going to develop once for xCloud. And when I say developed, it's more, you know, optimized, build, and so on. And in a sense, it's true, where you can indeed develop, and consider them as just another platform to build and optimize for. But if you do so, you are not going the cloud native way, in the sense that you are not leveraging, what can be done if you think about your game engine from a cloud point of view, from the creation of the game engine itself. So it's not a small, adventures there. Creating a game engine that is able to support modern AAA games. It can take, years and years and years to do it. So
Absolutely.
if you want to, think about everything that you have, and then transform everything that you have in a way that is going to be cloud native, so it can leverage different cloud providers, then it's going to take a lot of work. And if that work can be supported from at least the theoretical standpoint of the scientific community, say, okay, this should work, then together maybe we can test them out in the wild and see if it does work, and what are the the best approaches out there to create the cloud native game engine that can be then populated on different providers.
Perfect. It's a science fiction yet, but super cool.
No, it's a very interesting questions. It's simple questions that can be explored within the framework of Unity or some game engines that are out there. Is that one thing that you do thousands of times per seconds, it's collision and occlusion. So are stuff colliding with each other and it shouldn't bounce back?
Yeah.
And should you be able to see that stuff because it's not occluded by something else? So collision and occlusion. In a way, in a world where you are building a cloud engine, how do you want to, those two main services, or do you want to split them out? And how do you want to scale them up over time? Do you want to have a microservice that is computing collision just for you? So we spawn, one instance of the collision microservice just for you. Do you want to do the same for occlusion just for you? Or can you have a pool of occlusion services that are computing the occlusion for everyone within your vicinity, within the world? Because, if you are just next to each other, the occlusion should be almost exactly the same. And those questions are not, the answer is today, at least, is going to be, well, it depends what kind of games, what kind of experience you are trying to achieve. But I think we should go deeper than it depends and try to come up with architectures that are supporting this and measure what are the benefits and the drawbacks of those architecture in a scientific way.
Sure. Yeah, there's a lot of challenges. But Kendra, you have another question, that's it?
Yes, I do. Is there room for a question? Can you hear me?
Yeah.
Okay.
Yeah.
Yes, so I love the requirements in the architecture research. It's near and dear to my heart. And so your discussion on the issues with the traditional established architectural styles patterns, and yes, Gregory remains the current Bible, I would say. But you view this as primarily a refactoring problem so that you could leverage the cloud technologies, perhaps coming up with specifically tailored styles and patterns for games or other highly interactive systems with computer human interface, high priority requirements. I just want to hear your thoughts on that. So
I think, even I think, from Monash University, there is a workshop in ASE on, how to transform automatically, or it's from IBM, I don't remember, but there is a workshop happening where they show you how to transform your monoliths or your monoliths into microservices automatically and how to do recommendation. And if you take the architecture from Gregory and you say, okay, this is my base architecture, and you throw in some of the concerns and the requirements from video games, you could end up with a refactoring of your game engine that is recommended automatically and that accounts for video game specificities. And this is something we should do already to evolve our game engines toward a more cloud-able infrastructure. But there is also the going all the way from scratch. Thinking again about everything that you need to do, and what does it mean to do those things when you think cloud first, when it has been designed to run on distributed environment from the very beginning.
Yeah, I think people are inclined in many research communities to take an existing solution and tweak it. But I don't think tweaking is going to do the job in this case.
Yeah. So we try to apply the approaches that are out there, and it doesn't work for video games. So the requirements are too strong, and so we need something new in there.
This is a great research project. I'll catch up with you on this.
With pleasure.
So time runs fast when you enjoy and you have a lot of insightful and energized research to move on. But it's time to close, Kendra, Cristiano, and everyone.
Yes, so sad. But let me just bring up these remaining things. Just a sec, let me get my desktop reorganized. I apologize. Hang on.
I hope that you enjoy, that you did a good moments here, because sometimes organize a workshop, it's a nice pleasure, but sometimes little small trickies. And but I think finally you achieved the goals, huh?
This has been a very productive first workshop. Really focusing in on these, on this. I would call it a sub-community. It's crossing many areas, of course, but focusing on the automated issues, and in particular, how human beings still relate to that and are still needed. I think a lot of people think we're going to automate everybody into oblivion in software engineering, but I don't think that's going to happen. We need human beings because these are our users. We have to get their feedback. So I would just like to say thank you to everyone who's contributed, the program committee, our keynote speaker, organizers, and we just keep growing this community and expanding it. And I'd just like to say a special thank you for attending and hanging in there. And if you've got ideas on, what we could do in another version of this, send us email. There's the Discord. Fabio loves the Discord.
It works.
It works, okay. There's just a generic ASE4Games that goes to all four of the co-organizers, or you could just track us down with our other email address to discuss anything. I think that would leave it at that. That's a wrap for this workshop. Any other comments, Fabio, or from the participants?
Yeah, that's more from my side. We're starting to think about the opportunity, and today is here. I'm really shocked about the quality of papers, the quality of discussion, the quality of keynote. Thanks a lot, Mathieu, for your kind talk and sharing a lot of visions and ideas. So super, thank you so much. And I hope that you can participate next year. Maybe you can plan another version. If you'd like to participate in organizations, super welcome, super open, and to progress. the collaboration, to work together, to write together, take around, and Discord is there. Cristiano also worked super hard to organize the workshop. So it's for you, it's your community, and the community that you can create and improve. And I think this game is for fun. So I hope that you have fun this edition and you can have fun the next one.
Yeah,
And
just
if
got,
anyone have something to add, let's go ahead.
I've just got one quick announcement. Oh, we've driven people to drink. Look at this. Now I could have a great glass of wine. Okay,
Cheers.
cheers. Okay. Yeah, it's 10 in the morning over here, so not exactly wine time over here, but just a quick announcement. The an ICSE workshop proposal for 2022 was accepted. So it'll be the 6th International Workshop on Games and Software Engineering. The scope is a little bit broader, so if you've got work that isn't perhaps fully focused on automation, but automation is welcome as well. You can stay tuned for news on that. So we just heard last week, nothing else has been done on it. So we don't have a website or anything yet.
The GAS is a super cool conference workshop too. I participated previously. I know Kendra in this GAS workshop, so please submit on that because it's a nice environment. And it's in Pittsburgh this year. I hope that could be presential or maybe hybrid in the
don't know
ICSE
yet.
in general.
Yeah, we don't know yet. They're
You
still
don't
working
know
that
yet?
out. Yeah, they're working that out still.
Yeah, I'm a visualization chair in ICSE, so I know well that's not decided yet.
Not yet.
But I hope that you can meet as to be together another time.
Okay. Well,
So it's a closing.
yeah, should we wrap this up?
Closing
Okay.
time. So
Okay.
thank you so much. See you next time.
Thank you very much.
Thank you,
Bye-bye.
Shine.
Bye, thanks. Bye.
Thank you for all the attending. Thank you, Matthias. See you around.
See you guys.
Bye, guys. Thanks a lot.
Nice to meet you, Antonio. Bye-bye.
Bye-bye.
Thanks,
Bye.
Kendra. See you.